Across the vast expanse of the Old World, the period often described as the Copper Age marked a gradual yet measurable shift in the relationship between human communities, their environments, and emerging technologies. Archaeological research identifies this era, roughly between the 5th and 3rd millennia BCE in different regions, as a transitional interval situated between the long Neolithic and the later Bronze Age. Its chronology varies across Europe, the Near East, North Africa, and parts of Central Asia, but the broad pattern indicates a time when communities continued to rely on established agrarian foundations while slowly adopting new metallurgical practices. These developments did not occur uniformly. Instead, they emerged through local experimentation, regional exchange, and gradual refinement of techniques. Environmental studies suggest that many Copper Age landscapes were shaped by a combination of stable climates, expanding agricultural zones, and increasing modification of soils, forests, and waterways. In southeastern Europe and the Near East, settlements grew along river valleys and uplands that offered arable land, pasture, and access to stone, clay, and metal-bearing ores. Communities organized themselves in dispersed hamlets, clustered villages, or evolving towns, with architecture reflecting available materials such as mud brick, timber, and stone. Evidence indicates that many of these settlements were not isolated. They participated in networks that facilitated the movement of raw materials, crafted objects, and symbolic items across considerable distances. Metallurgy, although still limited in scale, began to occupy a distinct place within the technological choices of the period. Scholars emphasize that copper use did not immediately replace stone tools. Instead, metal supplemented traditional materials, often serving ceremonial or socially significant roles before becoming woven into routine economic activity. Excavations from the Balkans, the Levant, and the Caucasus reveal early smelting sites, mined ores, and workshops that illustrate a growing familiarity with metals' properties. These developments were gradual and regionally varied, shaped by access to ore sources, knowledge transmission, and local demands. Archaeological findings also suggest evolving patterns of social organization. Many communities maintained egalitarian structures inherited from earlier Neolithic traditions, while others developed visible markers of differentiation. Grave containing metal objects, finely crafted ceramics, or imported items indicate that status distinctions were emerging in some regions. These patterns were not universal, and many areas retained simpler social systems, but the broader trend points toward increasingly complex social landscapes. Alongside economic and social developments, symbolic and ritual practices continued to evolve. Figurines, decorated pottery, monumental enclosures, and regional cult sites indicate that Copper Age groups maintained rich symbolic traditions that connected households and communities to shared cosmologies. These expressions varied widely, shaped by local histories and long-standing cultural practices. Toward the end of the period, many regions experienced shifts influenced by population movement, climatic variability, technological innovation, and emerging long-distance exchange networks. These processes contributed to the wider adoption of metallurgy and the eventual transition into the Bronze Age. As the long arc of the Neolithic gives way to the early metalworking world, the history of the Copper Age offers a steady record of adaptation, continuity, and gradual transformation. From broad continental patterns to the daily routines of small settlements, the era reveals how communities responded to new materials and opportunities within familiar landscapes. With this groundwork established, the narrative now moves into the earliest origins of the Copper Age and the foundations that shaped its development. Across much of the Old World, the final phases of the Neolithic unfolded over centuries, marked by continuity, steady refinement, and gradual adaptation. Communities lived within landscapes that had been shaped by repeated cycles of cultivation, herding, and seasonal movement. Fields were cleared, soils were tended, and paths were worn between settlements that had already existed for generations. Archaeological research describes these communities as deeply rooted within their environments, with routines that reflected long familiarity with local climates and resources. The rhythms of daily life were governed by the growth cycles of crops, the needs of herds, and the predictable changes of each season. Within this stable framework, technological and social practices continued to mature, setting the stage for later developments associated with metallurgy. Climatic studies indicate that many regions experienced relatively stable conditions during the late 6th and early 5th millennia BCE. Although local variations existed, broad patterns suggest temperate or semi-arid environments suitable for cereal agriculture and mixed pastoralism. Households tended fields of wheat and barley, gathering yields that supported stored reserves during the colder months. Livestock herds, primarily sheep, goats, and cattle, moved between lowland grazing zones, upland pastures, or riverine corridors. These patterns formed interconnected systems in which plant cultivation and animal husbandry supported one another, providing reliable sources of food, fiber, and materials for tools and construction. Within these landscapes, settlements developed architectural traditions suited to local materials and communal needs. Excavations across southeastern Europe, Anatolia, and the Near East reveal structures built from mud brick, timber, wattle daub, or stone. Many settlements consisted of tightly clustered houses arranged around open courtyards or passageways, while others formed more dispersed patterns along ridgelines or riverbanks. The interiors of these structures often contained storage bins, hearths, and work areas for grinding grain, processing food, or crafting tools. Evidence of repeated rebuilding suggests that households remained in place for long periods, maintaining continuity across generations. Stone tool industries represented another long-standing foundation of Neolithic life. Communities produced blades, scrapers, axes, and adzes from flint, obsidian, and other workable stones. These tools fulfilled essential roles in farming, woodworking, hide processing, and the construction of dwellings. Archaeological analyses show that many communities maintained intricate knowledge of stone procurement, often traveling to quarries or exchanging material across regions. Techniques for pressure, flaking, polishing, and hafting had been refined over centuries, resulting in efficient and versatile toolkits. These practices would continue well into the Copper Age, even as metals slowly emerged as an alternative material. Pottery also played a central role in economic and domestic activity. By the late Neolithic, ceramic traditions had become highly developed, with communities shaping vessels for storage, cooking, and ceremonial use. Regional styles evolved through choices in clay temper, firing methods, surface treatment, and decoration. Some vessels carried simple utilitarian forms, while others featured intricate painted or incised patterns. The presence of standardized shapes suggests shared conventions and the transmission of knowledge across households and communities. Pottery production formed a stable technological base upon which later Copper Age ceramic traditions would build. Alongside these technological practices, social organization during the late Neolithic showed a mixture of continuity and subtle change. Many communities operated through cooperative labor arrangements, sharing responsibilities for construction, harvests, and seasonal tasks. Archaeological evidence from communal buildings and shared storage facilities indicates that certain activities were carried out collectively rather than individually. Burial practices, too, reveal patterns of shared identity, with multiple individuals sometimes interred within common structures or cemeteries. These practices suggest that communities viewed themselves as interconnected groups tied together through kinship, shared ancestry, or long-standing traditions. Ritual and symbolic behavior formed another layer of late Neolithic life. Figurines, decorated objects, and ceremonial spaces indicate that communities held beliefs connected to fertility, seasonal cycles, ancestors, or broader cosmological frameworks. In some regions, monumental structures hint at gatherings that brought together multiple groups for shared rites. These expressions varied widely across regions and should not be interpreted as uniform, yet they reveal a consistent emphasis on symbolic traditions that reinforced social cohesion. Over time, many of these practices influenced early Copper Age symbolic systems, suggesting a continuity of worldview even as new technologies appeared. Resource management formed a critical aspect of Neolithic foundations. Communities monitored the productivity of fields, the availability of grazing land, and the durability of construction materials. Evidence from pollen cores and sediment studies indicates that landscapes were gradually shaped by repeated cultivation, selective burning, and the controlled movement of livestock. In some regions, forests receded as fields expanded, while riverbanks were stabilized through ongoing habitation. These incremental changes produced environments that were familiar, manageable, and often optimized for the needs of settled agricultural societies. Regional interaction during this period also played a significant role in shaping cultural and economic patterns. Long-distance exchange networks, GH Limited compared to later eras, enabled the movement of prized materials such as obsidian, marine shells, and pigments. These items traveled between settlements through reciprocal exchange, kinship ties, or seasonal gatherings. The movement of objects also facilitated the sharing of knowledge and techniques, contributing to broader cultural cohesion across regions. Such networks would eventually support the transfer of early metallurgical practices, though at this stage they primarily served to reinforce existing Neolithic lifeways. As centuries passed, these combined elements, stable subsistence systems, refined craft traditions, established settlements, and shared social structures, created an enduring foundation. The late Neolithic world did not experience rapid transformation. Instead, it followed patterns of gradual adaptation shaped by environmental conditions and accumulated knowledge. These foundations are essential for understanding the emergence of early experimentation with copper. When communities eventually encountered native copper or ore deposits, they did so within systems that were already complex, resilient, and deeply rooted in local landscapes. Toward the close of the late Neolithic, subtle changes began to appear in certain regions. Archaeological research identifies shifts in settlement size, craft specialization, and long-distance exchange. Some communities expanded their territories, while others began to produce goods with increasing skill and efficiency. These developments did not represent a departure from Neolithic traditions, but rather an evolution within them. They suggest that households and groups were continually refining their practices, adjusting to new opportunities while maintaining older forms of organization. These slow, steady processes form the essential backdrop for the first appearance of copper tools and ornaments. Early encounters with metal occurred within societies that already possessed highly developed technologies and cohesive social frameworks. The presence of copper did not immediately alter daily routines or economic systems. Instead, it entered a world shaped by stone, clay, timber, and shared communal practices, materials and traditions that had defined human life for millennia. The late Neolithic foundations, therefore, represent a landscape of stability, familiarity, and long-standing adaptation. Their depth and resilience help explain why the earliest stages of metallurgy emerged gradually and unevenly across regions. As these communities continued to cultivate fields, tend herds, and rebuild their dwellings, the conditions were quietly forming for a new material to enter their world. Across many regions, the final Neolithic centuries continued to shape patterns of settlement growth. Some villages exhibited signs of gradual expansion, with additional structures built around earlier cores. Others reveal evidence of shifting habitation patterns as households relocated within familiar territories to take advantage of new water sources, fertile soils, or defensible terrain. Archaeologists caution against assuming uniformity, noting that each region developed according to its own ecological and cultural circumstances. Yet across these varied landscapes, a shared theme persists. Communities responded to their environments through measured adjustments rather than abrupt reorganization. These adjustments allowed groups to maintain continuity while exploring new possibilities in craft, architecture, and subsistence. Household economies in the late Neolithic were characterized by integration rather than specialization. Members of a household processed crops, stored food, shaped pottery, and repaired tools as part of regular domestic activity. Seasonal rhythms influenced the allocation of labor, with certain times of year devoted to intensive fieldwork, while others allowed for more attention to crafts or maintenance tasks. Archaeological remains, such as grinding stones worn by repeated use or clay-lined pits for storing cereals, suggest that such activities unfolded within well-established routines. These routines not only ensured stability, but also preserved knowledge across generations, creating durable frameworks within which later technological experimentation could occur. Textile production formed another component of domestic life during this period. Impressions found on pottery or preserved fibers indicate that weaving and spinning were practiced widely. These activities produced garments, bags, and coverings that contributed to household resilience. Although textiles rarely survive in the archaeological record, the tools associated with their manufacture, spindle whorls, loom weights, and needles, provide substantial insight into the importance of cloth making. The presence of these tools across multiple sites demonstrates that knowledge of textile production was broadly distributed rather than confined to specific individuals. This broad distribution reflects the communal character of Neolithic technological knowledge, which would continue to influence early Copper Age practices. Another aspect of Neolithic life that carried significant long-term implications was the management of livestock. Herding strategies varied according to local terrain, with communities in plains regions often favoring larger cattle herds, while upland areas relied more heavily on sheep and goats. Seasonal transhumance, where animals were moved between summer and winter pastures, occurred in some areas, while in others herds remained closer to settlements. Evidence from animal bones, enclosures, and dung layers indicates that livestock were integrated into the broader agricultural system. They provided meat, milk, hides, and labor, while their manure enriched cultivated fields. Over time, these interdependent practices helped shape landscapes that supported increasingly stable and sedentary populations. The late Neolithic also witnessed the refinement of storage strategies, a development that had considerable influence on economic stability. Communities constructed pits, silos, and ceramic containers to store harvested grain and dried foods. In some regions, archaeologists have identified large communal storage facilities, suggesting shared responsibility for safeguarding essential resources. These facilities buffered households against environmental fluctuations, enabling long-term planning and reducing vulnerability to poor harvests. Storage capacity also contributed to population growth, as communities could rely on reserves during lean seasons. This gradual strengthening of food security created conditions that would later allow experimentation with new materials, such as copper, without compromising the subsistence base. Trade and exchange networks continued to mature during the late Neolithic, facilitating the movement of goods across varied geographic zones. These networks connected coastal regions to inland valleys, highland settlements to lowland plains, and small villages to emerging regional centers. Obsidian from volcanic regions, distinctive pottery styles, beads made from exotic stones, and even perishable items like pigments likely traveled along these routes. The mechanisms of exchange remain a topic of scholarly debate, with possibilities including reciprocal gifting, kin-based interactions, or periodic gatherings that brought communities together. Regardless of the specific mechanisms, the presence of non-local materials demonstrates that late Neolithic societies maintained a level of connectedness that helped transmit technologies and ideas across large territories. As these networks expanded, they also contributed to the gradual diversification of material culture. New ceramic designs appeared alongside older forms, and variations in house construction reflected regional preferences. Some communities adopted new decorative motifs, while others continued long-standing traditions with minimal change. These developments highlight the complex interplay between innovation and continuity that characterized the late Neolithic. The introduction of new ideas did not replace older practices, but rather merged with them, producing blended cultural landscapes. Such blended landscapes would eventually provide fertile ground for the acceptance of metal objects when they first appeared. The social dynamics of late Neolithic communities reflected these broader currents of continuity and gradual transformation. While many groups maintained egalitarian or loosely structured social systems, archaeological evidence indicates that some regions were beginning to experience subtle shifts in social differentiation. Variations in grave goods, differences in house size, and the presence of specialized items suggest that roles within communities may have become more defined. However, these patterns varied considerably, and scholars caution against viewing them as clear indicators of hierarchy. Instead, they likely reflect the emergence of diverse social identities shaped by lineage, occupation, or ritual significance. These identities contributed to the broader cultural fabric in which technological experimentation later took place. Ritual practices continued to influence community life during this period, providing shared frameworks for interpreting seasonal cycles, life transitions, and communal events. Archaeological evidence from shrines, decorated figurines, and ritual deposits suggests that communities dedicated time and resources to maintaining symbolic traditions. These practices reinforced social cohesion and linked households to broader networks of meaning. In some regions, elaborately decorated spaces or communal structures indicate that ritual gatherings played an important role in consolidating group identity. These shared traditions contributed to cultural stability, ensuring that technological changes were absorbed within familiar symbolic frameworks rather than causing disruption. Across these varied domains, agriculture, architecture, craft production, social organization, and ritual behavior, the late Neolithic world maintained a sense of steady continuity. The conditions that shaped everyday life were deeply familiar, refined through long experience, and adapted to local environments. Within this setting, communities developed the capacity to manage change gradually. They could incorporate new tools, new techniques, and new ideas without altering the fundamental structure of their societies. This capacity for measured adaptation would prove essential as early metallurgical experimentation began to emerge in later centuries. By the close of the late Neolithic, the landscapes of many regions bore the imprint of centuries of human activity. Fields had been cultivated repeatedly, networks of footpaths connected settlements, and raw materials were drawn from well-known quarries, forests, and riverbeds. These landscapes were not untouched environments, but dynamic spaces shaped through long-term interaction between communities and their surroundings. Within them, daily life unfolded according to established rhythms supported by robust subsistence systems and enduring cultural traditions. As these quiet patterns continued, they set the groundwork for the gradual incorporation of copper into human technological repertoires, a development that would build upon the deep foundations laid during this final stage of the Neolithic. The chapter rests here, within a world defined by continuity, familiarity, and persistent refinement, a world in which the seeds of later change had already taken root beneath long-established practices. Across the landscapes of the 5th millennium BCE, the first encounters with copper occurred quietly, woven into the established routines of late Neolithic communities. These early developments did not appear suddenly or uniformly. Instead, they emerged as small, localized experiments carried out by groups already deeply familiar with stone, clay, and bone. Archaeological evidence indicates that the earliest copper objects were shaped from native copper, a naturally occurring metallic form that could be collected from riverbeds, exposed veins, or weathered rock surfaces. Communities recognized its malleability and distinct appearance, and through simple hammering and shaping, they learned to fashion it into small items that complemented existing toolkits. These earliest metal objects, awls, pins, beads, and small blades, did not replace established stone tools. Stone remained essential for tasks requiring sharp edges or heavy impact, while bone continued to serve for weaving tools, needles, and handles. Copper offered a different set of properties. It could be hammered into fine, thin forms, polished to a distinct sheen, and shaped without requiring extensive heat. Its presence in archaeological sites, from southeastern Europe to Anatolia and the Levant, suggests that communities incorporated it selectively, using it where its qualities offered specific advantages or symbolic value. The simplicity of these items points to early experimentation rather than full technological transformation. Environmental context played a meaningful role in shaping the earliest forms of metallurgy. Regions with visible copper deposits or riverbanks that yielded native copper provided opportunities for repeated contact with the material. Southeastern Europe, particularly areas within the Balkan region, contains numerous ore sources that weather to produce accessible metallic fragments. Similarly, parts of Anatolia and the southern Levant offered landscapes where communities encountered copper during everyday activities such as collecting stones or foraging. These encounters created the foundation for early knowledge, and over time, repeated observations likely revealed patterns in the material's behavior. When hammered, it flattened rather than shattered. When heated slightly, it softened further. These properties gradually became part of a community's technological awareness. Archaeological studies indicate that early hammering practices were often simple and conducted within domestic settings. Hammerstones found near hearths or small work areas suggest that shaping native copper required no specialized infrastructure. The presence of small hammer flakes, tiny fragments produced when copper is worked, supports this interpretation. These activities appear to have been performed alongside other household crafts, such as pottery shaping or tool repair. The integration of copper into domestic contexts reflects the modest scale of early metalworking, as well as the continuity between new materials and older Neolithic traditions. As communities gained familiarity with the mechanical properties of native copper, some regions began experimenting with heat. The earliest evidence for small-scale smelting appears in contexts dating to the late 5th and early 4th millennia BCE. These finds are modest traces of slag, fragments of furnace linings, or residues on ceramic vessels, but they indicate a significant shift in technological understanding. Smelting required knowledge of fire control, awareness of mineral sources, and repeated experimentation with ore extraction. Scholars emphasize that these developments did not unfold in a single location or follow a uniform sequence. Instead, varied experiments occurred across different regions, shaped by local resources and technological traditions. One of the earliest recognized smelting traditions appears in southeastern Europe, where excavations reveal small installations capable of processing ore in limited quantities. These installations were not large workshops, but rather simple arrangements that may have been used intermittently. Their presence suggests that certain communities had begun to understand the transformation of mineral ores into workable metal, a process that required sustained observation and refinement. In the Near East, similar evidence points to early attempts at controlled heating of ores, though interpretations vary regarding whether these instances represent deliberate smelting or incidental exposure of minerals to high heat. The distinction is often subtle, and scholars acknowledge that experimentation could have occurred in multiple forms simultaneously. As metallurgy gradually developed, the movement of copper objects between regions played a key role in spreading knowledge. Small ornaments or tools found far from ore sources suggest that early metal items participated in exchange networks already well established during the Neolithic. Communities that did not have access to local copper encountered the material through interaction with neighboring groups. These encounters may have sparked curiosity or encouraged attempts to replicate the objects. Yet the adoption of copper remained selective. Many communities continued to rely on stone implements for most tasks, and the appearance of copper did not immediately alter subsistence or settlement patterns. The use of copper in symbolic or decorative contexts appears prominently in several early assemblies. Beads, pendants, and finely shaped pins suggest that copper held social or aesthetic value beyond practical functionality. Its distinctive color and malleability may have made it attractive for adornment or ritual deposition. Some graves contain copper items positioned alongside stone, bone, or ceramic objects, indicating that communities incorporated metal into broader symbolic practices. These patterns, however, differ significantly by region. In some areas, copper appears almost exclusively in utilitarian forms, while in others it is strongly associated with ornamentation. Such diversity reflects the localized ways in which communities encountered, interpreted, and valued the new material. The emergence of early metallurgy also coincided with continued refinement of existing technologies. Stone axes, flint blades, and obsidian tools remained widely used and often show evidence of increased specialization during this period. Rather than replacing stone, the introduction of copper added another layer of technical choice. Communities selected materials according to the needs of specific tasks, and preferences varied based on familiarity, availability, and tradition. The coexistence of stone and copper underscores the gradual nature of early metallurgical adoption, which unfolded within long-established technological frameworks. By the early 4th millennium BCE, copper had become a recognizable and valued material in regions actively experimenting with its properties. Its presence in domestic spaces, burial contexts, and exchange networks demonstrates a growing familiarity, though metallurgical knowledge remained unevenly distributed. Some communities engaged in sustained experimentation, while others used metal sparingly or not at all. Archaeological patterns reflect this diversity, illustrating the multifaceted nature of early technological change. Within this environment of gradual development, the foundations of copper use anchored themselves within everyday practices, domestic spaces, and shared cultural traditions. Metallurgy was not yet a specialized craft or a transformative industry. It remained an exploratory domain, shaped by incremental insights and governed by the rhythms of late Neolithic life. These early steps formed the quiet beginnings of a technology that in time would reshape economies and social structures, but at this stage remained closely tied to the familiar world from which it emerged. As the 4th millennium BCE progressed, the gradual spread of early metallurgical knowledge continued across regions already interconnected through exchange and seasonal movement. The appearance of copper items in areas far from ore sources indicates that objects traveled through well-established networks long before large-scale production emerged. These networks did more than simply move materials. They facilitated the passage of ideas, techniques, and observations. When a community encountered a copper ornament or tool obtained from another region, it gained insight into the properties of the material, even if the methods of production were not fully understood. This circulation played a crucial role in creating uneven but expanding zones of metallurgical awareness. Within settlements where copper use became more frequent, archaeological evidence points to increasing refinement in manufacturing techniques. Hammering became more controlled, with craftspeople learning to strike the metal in ways that minimized cracking. Repeated cycles of heating and hammering were applied to thin sheets or elongated forms, revealing an emerging mastery of annealing. This process, which softens metal through exposure to moderate heat, likely developed through practical observation rather than theoretical knowledge. When copper became difficult to shape, proximity to a hearth provided an intuitive solution. Over generations, these practices matured, becoming part of the technical repertoire of households or small workshop groups. Despite these advances, early smelting remained rare and highly localized. Archaeologists identify small amounts of slag, residues formed when ore is processed at high heat, which indicate controlled, deliberate attempts to convert mineral ores into usable metal. Yet the scale of these efforts appears limited. Furnaces, when present, were small and designed to process only modest quantities of ore. Many may have been built for singular or infrequent use. The experimental nature of these installations suggests that communities were still exploring the boundaries of what copper could offer. They did not yet possess the specialized equipment or dedicated labor required for continuous production. Ore extraction also remained minimal during this early phase. In regions such as the Balkans and Anatolia, shallow pits or exposed veins show signs of early quarrying activity, but these efforts were modest compared to later mining traditions. Communities collected ore from easily accessible deposits, bringing small amounts back to domestic spaces for experimentation. The labor required for deeper extraction was not yet justified by demand, and metallurgical knowledge had not advanced to the point where large-scale mining offered clear advantages. Instead, the earliest uses of copper relied on materials gathered from surface sources or naturally eroded deposits. The coexistence of new metallurgical techniques with long-established Neolithic crafts illustrates how early copper use fit into broader technological traditions. Pottery production continued to flourish, with vessels displaying increasingly diverse forms and surface treatments. Stone toolmaking remained a central component of daily life, and flint knapping techniques reached high levels of refinement. These traditions did not decline when copper appeared. Rather, they remained essential to community survival and daily activity. Early metallurgy functioned as an addition to existing crafts rather than an alternative, and its development did not displace inherited knowledge. Social contexts played an equally important role in shaping early metallurgical practices. In some regions, copper items appear in burials that contain other markers of social distinction, suggesting that metal may have carried symbolic or status-related significance. Beads, pins, or small tools made of copper were often found alongside carefully arranged grave goods. These associations indicate that copper was sometimes valued not only for its practical qualities, but also for its visual or symbolic properties. However, such patterns were not universal. Many communities continued to treat copper as a utilitarian material, using it primarily for small functional objects. This diversity reflects the varying cultural meanings assigned to metal during its earliest adoption. Ritual contexts also provide insight into early metallurgical significance. In several regions, copper objects are found in sites associated with ceremonial activities, suggesting that metal held a place within symbolic systems already linked to figurines, decorated pottery, or carved stone objects. Whether copper took on specific ritual meaning or was valued simply for its distinct appearance remains uncertain, and interpretations vary among scholars. Nonetheless, its presence within such contexts demonstrates that communities recognized distinctions between this new material and older substances. One of the most notable characteristics of early metallurgy is its regional variability. In southeastern Europe, copper appears in relatively large quantities compared to neighboring areas, reflecting early and sustained experimentation. In Anatolia, metal objects occur within contexts that show long-standing craft traditions and regular interaction between settled communities. In the southern Levant, copper appears in both utilitarian and symbolic forms, while in nearby regions, its use remains rare until later centuries. These differences demonstrate that metallurgy did not follow a single developmental path. Instead, it emerged through parallel processes shaped by local resources, environmental conditions, and cultural preferences. Archaeological research continues to reveal the complexity of this early period. Studies of slag composition, furnace design, and metallurgical residues indicate that early craftspeople engaged in substantial trial-and-error experimentation. They tested different ores, explored temperature control, and developed new approaches to shaping metal. These efforts were incremental and cumulative, reflecting a method of learning grounded in repeated practice. Metallurgy advanced not through isolated breakthroughs, but through generations of observation and refinement. By the end of the 4th millennium BCE, the use of copper had become a familiar, though not yet dominant, feature of material culture in several regions. Communities incorporated metal objects into daily life, exchange networks, and symbolic practices. Although production remained small in scale, metallurgical knowledge had deepened. Techniques such as cold hammering, annealing, and basic smelting were understood in various degrees across different territories. Copper had become a recognized and valued material, one that coexisted alongside stone, bone, and ceramic. The quiet emergence of early metallurgy illustrates how technological change often unfolds slowly, shaped by environmental opportunities, cultural traditions, and shared human experience. Copper entered societies that were prepared to receive it, societies grounded in long-standing practices that offered room for careful experimentation. In this interplay between continuity and innovation, early metallurgy found its earliest form, settling gently into the fabric of daily life without displacing the deep foundations already established. Across the regions where early metallurgy gradually emerged, The landscapes of the 5th to 3rd millennia BCE formed a complex mosaic of climates, vegetation zones, and resource distributions. These environments provided the conditions within which Copper Age communities organized their subsistence systems, selected settlement locations, and shaped patterns of daily activity. Archaeological and paleo-environmental research highlights the depth of interaction between people and their surroundings during this era, revealing landscapes that were neither untouched nor heavily transformed, but continually shaped through cycles of cultivation, herding, and resource gathering. Within this dynamic interplay, copper-bearing regions became areas of particular significance, guiding the earliest developments of metallurgy. Climatic patterns across southeastern Europe, the Caucasus, and parts of the Near East were generally temperate during much of this period, though each region displayed its own environmental character. In southeastern Europe, the Balkan Peninsula experienced moderate rainfall, warm summers, and relatively cool winters. The seasonal cycles supported mixed economies based on cereal cultivation, herding, and foraging. Farther east, the Caucasus presented a sharply varied landscape, with humid lowlands, dry steppe zones, and high alpine environments existing in close proximity. These contrasts offered diverse ecological niches that communities exploited through mobility, small-scale agriculture, and animal husbandry. In the Near East, rainfall patterns were more variable, with the Levant receiving winter rains that supported agriculture, while adjacent regions experienced drier conditions requiring careful water management. Hydrological systems formed essential anchors for settlement and subsistence. Rivers, springs, and seasonal streams shaped the placement of fields and homes, offering reliable access to drinking water, irrigation, and fertile soils. In southeastern Europe, settlements often clustered near river valleys where alluvial plains provided rich agricultural zones. These watercourses also served as natural pathways, connecting inland settlements with coastal regions and facilitating the movement of goods and knowledge. In the Near East, the presence of perennial springs or seasonal runoff determined where small villages could thrive, particularly in areas with lower rainfall. Communities responded to these conditions by developing systems of water storage, soil management, and crop scheduling that aligned with local hydrological patterns. Vegetation zones across these regions varied widely, influencing the availability of building materials, grazing land, and wild resources. The forests of southeastern Europe offered oak, beech, and pine, providing timber for construction and fuel for domestic hearths. In the Caucasus, lower elevations supported woodland and grassland, while highland zones produced meadows that were ideal for seasonal grazing. The Near East featured a mixture of woodlands, scrub zones, and steppe environments, each supporting different forms of plant and animal life. These ecological differences shaped subsistence strategies, with communities balancing cultivation, herding, and resource collection based on local vegetation. The geological character of these landscapes played an especially significant role in the emergence of metallurgy. Areas rich in copper ores, particularly the Balkans, the Caucasus, and parts of Anatolia and the Levant, contain mineral deposits accessible through exposure, erosion, or shallow quarrying. In the Balkans, copper-bearing minerals such as malachite and azurite appeared in weathered outcrops, making them available to communities without the need for deep mining. The Caucasus offered similarly rich deposits, and its varied terrain exposed ore in multiple ecological zones. In Anatolia and the southern Levant, mineral sources occurred in both highland and desert margins, where erosion revealed copper-bearing stones that could be collected by hand. These mineral resources did not immediately lead to sustained metallurgical production, but they created the environmental conditions under which early experimentation could occur. Communities with access to exposed ore fragments or malachite-rich stones encountered copper in the course of daily activities, whether foraging, collecting building materials, or working nearby soils. Such encounters fostered the gradual recognition of copper's distinctive properties. In regions where ore was abundant, familiarity deepened more quickly, supporting early efforts at cold hammering, heating, or basic smelting. Where ore was scarce, metallurgy spread more slowly, often through trade and imitation rather than direct experimentation. Landscape modification was another characteristic feature of this era. Fields were cleared through repeated cultivation, with pollen studies showing gradual reductions in forest cover around many settlements. Grazing herds contributed to changes in vegetation patterns, particularly in steppe and upland zones where sheep and goats browsed heavily. Quarrying for stone needed for tools, building materials, and pottery temper left shallow depressions and altered slopes around long-occupied settlements. Although these changes were moderate compared to later periods, they demonstrate that Copper Age communities actively shaped their environments through sustained, routine activity. The interaction between subsistence strategies and environmental conditions formed the foundation for settlement density and distribution. In areas with fertile soils, dependable water, and accessible resources, settlements tended to cluster more closely and display signs of continuity across generations. In more marginal environments, communities remained mobile or semi-sedentary, adjusting their movements to seasonal resource availability. These settlement patterns influenced the spread of metallurgy, as regions with dense networks of villages facilitated the movement of knowledge and materials more readily than sparsely populated areas. Exchange routes followed rivers, mountain passes, and coastal pathways, linking communities across diverse ecological zones. Technological experimentation often aligned with the availability of raw materials. In regions where clay was abundant, pottery became increasingly refined. Where high-quality stone was accessible, flint knapping and groundstone toolmaking continued to advance. When copper ores could be easily collected, experimentation with heat and hammering naturally followed. Archaeological evidence suggests that these developments were not deliberate technological revolutions, but responses to the resources at hand. Communities used what their landscapes offered, adapting their practices through observation and incremental refinement. Through these interactions, the environment played a central role in shaping Copper Age lifeways. Climate provided the rhythms that guided agricultural cycles. Hydrology anchored settlements and supported pastoral movement. Vegetation zones supplied building materials and grazing land. Geological formations determined where communities first encountered copper and whether they continued to work with it. Together, these factors created a tapestry of environmental conditions that both constrained and enabled early technological development. Across the regions where early metallurgy emerged, the accessibility of copper-bearing minerals shaped not only technological experimentation, but also patterns of mobility and localized resource use. Communities living near exposed ore deposits often incorporated short trips to mineral-rich zones into their seasonal routines. These excursions were likely small in scale, undertaken by individuals or small groups familiar with the surrounding terrain. The collection of malachite-stained stones or native copper fragments occurred alongside other resource-gathering activities such as harvesting wild plants, gathering clay, or sourcing timber. Over time, these repeated journeys established a network of well-used paths connecting settlements to ore-bearing landscapes, reinforcing regional familiarity with mineral-rich areas. In the Balkans, for example, many settlements were situated within walking distance of copper sources, allowing communities to access raw materials without extensive logistical planning. Archaeological evidence from these regions shows concentrations of mineral fragments within domestic spaces, suggesting that ore was occasionally brought home for experimentation or symbolic use, even before consistent smelting practices were established. Similar patterns appear in parts of Anatolia and the southern Levant, where mineral-bearing zones intersected with seasonal grazing routes or trading paths. These overlaps ensured that early metallurgy developed within the broader framework of established mobility patterns rather than requiring entirely new forms of resource acquisition. The varied topography of these regions also played a significant role in shaping community strategies. In mountainous or hilly areas, settlements often occupied elevated or terraced positions that offered natural defensibility, access to grazing land, and proximity to mineral sources. These sites typically provided panoramic views of surrounding valleys, allowing communities to monitor seasonal changes, track herd movements, and assess environmental conditions. In contrast, lowland settlements were positioned near rivers or wetlands where fertile soils supported intensive agriculture. The combination of arable land and nearby water made these zones attractive regardless of access to copper ores, and it was through exchange and interaction rather than direct extraction that metal reached some of these communities. Climate fluctuations during these centuries contributed subtle yet meaningful variations in environmental abundance. Paleoclimatic studies suggest that intervals of slightly increased aridity or shifts in rainfall distribution occasionally influenced the availability of pasture, the productivity of fields, or the stability of water sources. Communities responded pragmatically to these changes, adjusting herd management strategies, modifying crop choices, or altering settlement placement where necessary. These adaptive responses ensured the continuity of subsistence systems and allowed technological practices, including early metallurgy, to maintain their slow and steady development. The resilience of these communities reflects the intimate knowledge they held of local climatic rhythms and the flexibility embedded within their agricultural and pastoral strategies. In addition to shaping subsistence routines, environmental conditions influenced the distribution of craft production. Areas with plentiful clay supported the creation of pottery kilns and the development of diverse ceramic traditions. Regions with dense forests supplied fuel for domestic hearths, pottery firing, and the earliest metallurgical experiments. Woodland availability was particularly important for smelting, as ore reduction required sustained heat and consistent fuel supplies. While the earliest smelting efforts were small in scale, they nonetheless relied on the careful management of nearby vegetation. Communities monitored forested areas, gathering dry branches, cutting small trees, or managing coppice growth to maintain fuel availability. These activities left subtle traces in pollen records and soil composition, revealing local patterns of woodland use. The presence of other minerals contributed to broader material traditions as well. Obsidian, limestone, sandstone, and silicious rocks continued to serve as essential raw materials for tool-making, building, and ritual objects. Their distribution shaped regional preferences and influenced patterns of exchange. In some areas, high-quality flint sources created local centers of stone tool production, while in others, the availability of volcanic glass supported established networks that transporting obsidian across considerable distances. These networks later facilitated the spread of copper objects, revealing the interconnected nature of resource economies during this era. Pastoral practices also played an influential role in landscape engagement. Herds of sheep and goats moved across upland pastures and lowland meadows, shaping vegetation patterns through repeated grazing. Seasonal cycles of movement linked distant ecological zones, ensuring that communities remained familiar with a wide range of environments. These patterns contributed to a shared regional understanding of mineral-bearing terrain. A shepherd encountering green or blue stones in a pasture, or a traveler noticing metallic outcrops along a mountain path, may have introduced new mineral sources to the community, gradually expanding the landscape of early metallurgical knowledge. Such discoveries were woven into existing mobility traditions rather than standing apart as specialized expeditions. Settlement density varied significantly by region, reflecting differences in environmental productivity and the distribution of resources. Areas with rich soils and dependable water sources often supported clusters of villages where population continuity spanned multiple generations. In these regions, archaeological evidence points to deeper accumulations of cultural material, more complex architectural sequences, and rich craft traditions. These settlements acted as hubs within broader networks, distributing pottery, stone tools, and eventually metal objects to surrounding communities. Regions with more marginal landscapes tended to have smaller, more dispersed settlements connected through seasonal gatherings or kinship-based ties. Resource accessibility influenced not only settlement patterns, but also the pace and nature of technological development. In regions where copper ores were abundant and easily accessed, early experimentation with smelting and shaping occurred more frequently. Conversely, in areas where copper was scarce, communities relied on exchange networks to acquire metal objects and were slower to develop independent metallurgical traditions. This uneven distribution highlights a fundamental relationship between environment and technology. Early metallurgy did not emerge uniformly, but followed the contours of local geology, hydrology, and social interaction. Hydrological systems, in particular, structured the movement of goods and knowledge. Rivers acted as conduits for interaction, with settlements lining their banks and traders or travelers following their courses. Copper items found along major river valleys often reflect exchange rather than direct production, suggesting that metallurgical knowledge moved outward from areas of early innovation through established channels of communication. In coastal zones, maritime routes facilitated contact between distant regions, allowing metal objects to travel alongside pottery, shells, textiles, and pigments. Throughout these centuries, landscapes remained active participants in human life. The environment offered resources, imposed limitations, and shaped choices. Communities responded through practices that balanced the demands of subsistence with the opportunities presented by mineral-rich terrain. The emergence of metallurgy, though modest at first, unfolded fully within this environmental matrix. Copper became part of the material world not because communities sought radical change, but because their surroundings offered new possibilities that aligned with existing habits of observation, mobility, and resource use. By the end of the 3rd millennium BCE, these landscapes had supported several centuries of slow, interconnected development. Fields bore the marks of repeated cultivation, forests showed patterns of managed use, and mineral-bearing zones had become familiar landmarks within regional geographies. The environment had shaped the early story of metallurgy, guiding its emergence through steady interactions rather than abrupt transformation. As these practices settled into the broader rhythms of daily life, the landscapes themselves remained constant companions, providing the foundation upon which future metallurgical traditions would continue to evolve. Across the mid-5th to late 4th millennia BCE, the subsistence systems of Copper Age communities rested on long-established agricultural and pastoral foundations. These practices, refined over generations, provided stability in landscapes marked by seasonal rhythms and gradual environmental change. Archaeological evidence from settlements across southeastern Europe, the Near East, and the Caucasus reveals households engaged in a broad spectrum of subsistence activities. These activities formed a balanced economic structure capable of sustaining growing populations, while also supporting the emerging craft traditions that characterized this transitional era. Agricultural routines centered around the cultivation of cereals and legumes, with wheat and barley forming the most consistent crops across regions. These grains thrived under varied climatic conditions and provided reliable yields when managed carefully. Fields were prepared through repeated cycles of tillage, sowing, weeding, and harvesting, with households coordinating labor according to seasonal demands. The sowing season typically coincided with the onset of wetter months, while harvests took place once warm, dry conditions ensured adequate drying of grain. Legumes such as lentils, peas, and chickpeas complemented cereal production, enriching diets and adding resilience to agricultural systems. Their inclusion reflects an understanding of crop stability and soil management that had developed over many centuries. Livestock management functioned alongside agriculture as a pillar of subsistence. Sheep and goats formed the core of herd compositions, valued for their adaptability, meat, milk, and wool. Cattle, though fewer in number, served as sources of traction, hides, and meat, and in some regions became markers of wealth and social significance. Herding strategies varied according to terrain and climate. In lowland zones, herds grazed near settlements or moved short distances between fields and meadows. In upland areas, communities practiced more extensive mobility, guiding animals toward mountain pastures during summer months and returning them to sheltered valleys in winter. These seasonal routines connected communities to broader landscapes, reinforcing patterns of movement that shaped regional identities and facilitated contact with neighboring groups. Hunting, fishing, and foraging continued to play important roles in daily life. Even in fully agricultural communities, wild game supplemented diets and contributed valuable resources. Evidence from faunal remains shows the presence of deer, wild boar, hare, and various bird species in domestic refuse. Riverine and coastal settlements incorporated fish, mollusks, and crustaceans into their subsistence structures, while inland groups relied on streams, marshlands, or seasonal pools for freshwater species. Foraging for nuts, berries, wild greens, and edible roots remained a routine activity, providing dietary variety and certain seasonal nutrients difficult to obtain from cultivated crops alone. These practices reveal that Copper Age economies retained a flexible relationship with local ecosystems, incorporating domesticated and wild resources into integrated strategies. Seasonal scheduling formed the foundation of economic planning. Communities organized labor around predictable cycles: autumn sowing, winter maintenance, spring preparation, summer harvests, and periodic tasks associated with livestock care. These rhythms structured daily life and influenced the timing of craft production. During periods when agricultural workloads were lighter, often in late winter or early spring, households engaged more intensively in activities such as pottery shaping, textile processing, woodworking, and the maintenance of tools. These crafts were not isolated from subsistence, but woven into the broader fabric of economic life, shifting in intensity according to the agricultural calendar. Craft production grew in complexity during this period, supported by stable subsistence systems. Textile manufacturing expanded across many regions, with spindle whorls, loom weights, and preserved impressions revealing diverse weaving traditions. Wool from domesticated sheep, alongside flax in some areas, provided the raw materials for cloth well suited to varying climates. Pottery production also matured, with vessels adapted for storage, cooking, carrying water, and participating in social or ceremonial activities. Kilns and open firing techniques were refined to produce more consistent results. These craft traditions, grounded in routine household labor, contributed to surplus production and enabled communities to meet both local needs and external demands. Limited but significant metalworking appeared as part of this expanding craft horizon. Early copper objects, awls, beads, and simple tools were often produced within domestic spaces or small workshop zones. While metallurgy did not yet dominate economic activity, its development was closely tied to the stability provided by diversified subsistence systems. Communities could engage in experimentation because their agricultural and pastoral foundations were strong enough to support periods of non-subsistence labor. Copper thus entered the economic world gradually, integrated into existing craft schedules rather than standing apart from them. Regional exchange networks played a growing role in Copper Age economic life. Communities traded cultivated goods, animal products, and crafted objects across local and long-distance routes. Obsidian, prized for its sharp edges and aesthetic qualities, moved across regions through well-established networks originating in volcanic zones. Salt, essential for preserving food and maintaining livestock health, traveled from coastal or inland salt sources to settlements lacking access to it. Marine shells found far from coastlines indicate their role as exchange items or decorative materials, while pigments and stones used in figurines or ornaments circulated through networks shaped by social ties and seasonal gatherings. These exchange systems contributed to economic resilience. When local resources fluctuated or harvests varied, communities could draw upon relationships with neighboring groups. The movement of goods also encouraged the spread of ideas, techniques, and new materials, including early metal items produced in regions with access to ore. The presence of copper objects in areas without mineral resources demonstrates how exchange supported the early tags of metallurgical diffusion, enabling communities to encounter new tools and ornaments that complemented their existing craft traditions. Throughout these centuries, subsistence practices and economic frameworks formed a stable and adaptable foundation for daily life. Communities balanced cultivation, herding, foraging, and craft production within systems shaped by local landscapes and long-standing traditions. These systems supported the emergence of early metallurgical practices not through deliberate technological revolution, but through an accumulation of economic stability, diversified activity, and regional connectivity. As Copper Age households continued to refine their subsistence routines, they created the conditions in which experimentation, exchange, and gradual technological change could quietly unfold. As the Copper Age unfolded, the interdependence between subsistence systems and craft production became increasingly evident. Agricultural surpluses, even if modest, created intervals during which households could devote time to tasks beyond daily survival. These moments allowed for experimentation with new materials and techniques, including those related to early metallurgy. The stability provided by reliable harvests and established herding routines enabled communities to diversify their economic activities without jeopardizing essential food supplies. This balance between necessity and innovation shaped the broader character of Copper Age economies. Storage systems played a vital role in sustaining this balance. Archaeological excavations reveal a variety of storage facilities, from clay-lined pits to large ceramic jars placed within household interiors. These containers safeguarded cereals, pulses, dried fruits, and animal products, ensuring that food remained available throughout the year. Effective storage reduced vulnerability to seasonal shortages and allowed communities to plan beyond immediate needs. Surplus grain, in particular, became an important material within exchange systems, as households could trade portions of their harvest for goods not locally available. The ability to store food reliably thus supported both security and economic interaction. The management of livestock contributed further to economic flexibility. Herds served as mobile reserves of wealth, capable of producing milk, wool, meat, and hides according to seasonal requirements. Sheep and goats responded well to varied environments and could forage in areas unsuitable for cultivation, making them ideal for regions with uneven terrain. Their movement across landscapes had lasting effects on vegetation, creating grazing patterns that communities learned to navigate and manage. Cattle, though less numerous, offered strength for land clearance and the transport of goods. In some areas, the presence of cattle enabled heavier plow techniques or the preparation of more expansive fields, supporting greater agricultural output. These combined herding practices created a dynamic interplay between animals, land, and labor. Craft specialization developed gradually within this broader economic context. While most production remained tied to household or village-level activity, certain traditions began to show signs of increasing skill concentration. In pottery, some settlements produced vessels with distinctive forms or decorative motifs that spread across neighboring regions, indicating the presence of potters with advanced expertise. Textile production also displayed regional distinctions, with variations in spinning techniques or weaving patterns suggesting the development of locally preferred styles. These craft traditions were often seasonal, linked to intervals between agricultural tasks, yet they contributed meaningfully to economic identity and exchange relationships. In regions where copper ores were accessible, metallurgical practices became another component of domestic craft production. Communities collected ore fragments during excursions into mineral-bearing areas and brought them back to settlements for small-scale processing. Hearths, already essential for cooking and pottery firing, provided the heat needed for annealing copper during hammering or shaping. Although smelting remained limited, households that experimented with ore reduction did so within familiar workspaces rather than specialized facilities. Over time, the knowledge gained through these experiments contributed to the refinement of local techniques and the creation of more complex objects. Economic diversification created opportunities for communities to engage with their neighbors more frequently. Seasonal gatherings, trading encounters, and shared ritual events facilitated the exchange of goods and information. Obsidian continued to move across long distances, maintaining connections between volcanic source regions and settlements hundreds of kilometers away. The circulation of shells, beads, and pigments reveals that symbolic items were valued across cultural boundaries. These objects traveled along routes shaped by kinship ties, reciprocal exchange, or periodic meetings at neutral gathering places. The stability provided by agricultural and pastoral systems made participation in these networks possible, as communities could allocate time and resources toward interaction. The movement of early metal items through these networks illustrates how metallurgy became embedded within existing economic frameworks. Copper awls, beads, and pins found in regions without ore sources demonstrate that communities valued metal even before they developed the means to produce it themselves. These objects served practical and symbolic purposes, reflecting the integration of metal into daily and ceremonial life. Over time, repeated exposure to metal items encouraged attempts to replicate them, especially in regions where ore was accessible. Thus, economic interaction played a central role in spreading metallurgical knowledge, linking subsistence practices to technological adoption. Seasonal mobility patterns further influenced economic life. In areas where pastoralism occupied a significant role, the movement of herds connected highland and lowland zones, bringing communities into contact with a wide range of environments. These journeys exposed herders to geological features such as mineral-rich streams, eroded outcrops, or distinctive stone deposits. Such encounters may have informed the broader community about potential resource zones, indirectly contributing to the identification of copper-bearing areas. The integration of pastoralism into Copper Age economies therefore supported not only subsistence, but also the discovery and exploitation of new materials. Fishing and aquatic resource use shaped the economies of riverine, marshland, and coastal settlements. Nets, hooks, and small boats supported the capture of fish species that provided essential protein, especially during seasons when terrestrial hunting was limited. The presence of fish remains in settlement sites indicates that these resources formed a regular component of diets. In regions near lakes or marshes, communities collected reeds and other water plants for basketry, roofing, and tool-making, demonstrating the interconnectedness of aquatic environments and craft traditions. The integration of wild and domestic resources contributed to the resilience of Copper Age economies. When crop yields fluctuated due to weather or local soil conditions, communities relied on grazing, wild plants, or stored reserves to maintain stability. This flexibility reduced vulnerability to short-term disruptions and supported long-term continuity. It also encouraged households to maintain knowledge across multiple domains: farming, herding, gathering, and craft-making, ensuring that no single practice became overly dominant or fragile. Economic activity during this era was not governed by central authorities or large-scale institutions. Instead, it unfolded through localized decision-making, shared traditions, and cooperative labor. Households operated within networks of mutual dependence, contributing to and benefiting from collective tasks such as harvesting, building, or managing water resources. These cooperative practices supported the development of economic systems that were both adaptable and capable of sustaining incremental innovation over long periods. By the close of the late 4th millennium BCE, these subsistence and economic frameworks had become deeply rooted within the daily rhythms of Copper Age life. Communities continued to cultivate familiar crops, tend herds, and refine their craft traditions within landscapes shaped by generations of activity. These enduring practices formed the stable foundation upon which early metallurgy could develop. As households engaged in routine tasks, crafted new objects, and participated in regional exchange, they supported a slow but steady expansion of technological possibilities that rested securely within the resilience and diversity of their economic worlds. The chapter settles here, among the integrated systems of cultivation, herding, gathering, and craft production that sustained the Copper Age and allowed its technological horizons to widen gently over time. Across the centuries between roughly 4500 and 3500 BCE, settlement landscapes in Copper Age regions reflected a gradual but perceptible transformation in how communities organized themselves within their environments. These changes did not occur suddenly or uniformly. Instead, they unfolded through local adaptations, long-standing traditions, and the practical needs of daily life. Archaeological excavations from southeastern Europe, Anatolia, and the Near East reveal a spectrum of settlement forms, ranging from modest hamlets composed of a handful of households to more substantial villages exhibiting signs of coordinated planning, and in some areas, the earliest hints of proto-urban organizati. Together, these sites provide insight into how Copper Age populations constructed their built environments and structured their social relationships. At the smaller end of the spectrum, many communities lived in compact clusters of dwellings, often situated along river valleys, foothills, or fertile plains. These hamlets typically consisted of a few houses arranged near shared workspaces or open areas. Their architectural forms varied according to available materials. Mud brick walls rested on stone foundations in some regions, while timber frames coated with clay were preferred in others. Roofs of thatch, reeds, or packed earth provided shelter from seasonal weather. In these smaller settlements, households operated with considerable autonomy, yet they often shared tasks such as food storage, field clearance, and maintenance of communal pathways. As settlements expanded, architectural layouts became more structured. Excavations in southeastern Europe show villages with houses positioned in orderly rows or oriented around central courtyards. These layouts suggest that households coordinated their construction activities, possibly following traditional spatial guidelines that had developed over generations. In Anatolia and the Caucasus, some settlements included multi-room houses, indicating more complex household arrangements and the allocation of interior spaces to specialized activities such as grain storage, weaving, food processing, or craft production. These architectural patterns reflect both continuity with earlier Neolithic traditions and incremental innovation shaped by shifting economic and social needs. Communal facilities formed an important element of many Copper Age settlements. Open courtyards, shared ovens, and large storage structures demonstrate cooperative labor and collective responsibility. In some regions, particularly in the Balkans, archaeologists have identified large, well-built structures interpreted as communal halls or gathering areas. These spaces may have served for meetings, feasting, or ritual activities, though interpretations vary. Their presence suggests that communities valued shared activities and recognized the need for locations where collective decisions or seasonal events could be coordinated. Even in settlements without large communal buildings, open areas within the village acted as centers of shared activity. Storage systems reveal further insight into settlement organization. Many communities constructed dedicated storage pits lined with clay or stone, either within individual houses or in shared spaces. These facilities safeguarded grain, legumes, and other food resources, enabling households to maintain reserves across seasons. In larger settlements, clusters of storage installations suggest coordinated production and shared management of resources. The placement of storage facilities often reflected social relationships. Some households maintained independent storage capacities, while others participated in broader networks of mutual reliance. Archaeologists interpret these patterns as indicators of emerging differentiation in household roles and responsibilities. Burial practices provide another lens through which social organization can be examined. In many regions, individuals were interred within or near settlement boundaries, often beneath house floors or in designated burial areas adjacent to dwellings. These practices reinforce ties between the living community and ancestral presence, suggesting continuity across generations. Grave goods varied in quantity and type. Some burials contained only simple pottery or personal ornaments, while others included items such as stone tools, decorated vessels, or early metal objects. The distribution of these goods does not necessarily indicate rigid hierarchy, but it does reflect emerging distinctions in personal identity, social role, or household status. These patterns remain subtle during this period, consistent with overall tendencies toward egalitarian structures inherited from earlier Neolithic lifeways. In certain regions, more pronounced differentiation began to appear. Larger houses with multiple rooms, specialized pottery styles associated with particular households, or concentrations of high-quality tools suggest that some families or groups held greater economic or social influence. These distinctions, however, did not fundamentally alter the cooperative nature of settlement life. Archaeological evidence shows that shared labor continued to underpin agricultural, pastoral, and craft activities. The emergence of social differentiation therefore appears as a layered development, incremental, regionally variable, and integrated within long-standing communal frameworks. As settlements grew in size, they also developed more defined internal spatial organization. Pathways emerged between houses, forming circulation routes that guided movement within the community. Waste disposal areas located near settlement edges indicate a conscious effort to maintain hygienic living conditions. In some cases, boundaries or perimeter structures suggest attempts to manage livestock, protect stored goods, or delineate household spaces. Such features demonstrate an increasing attention to spatial planning, shaped by the practical needs of larger populations living in closer proximity. Regional variation in settlement forms remained significant. In the Near East, some communities constructed distinctive rectangular houses with standardized room arrangements, reflecting shared architectural traditions across wide areas. In the Caucasus, settlements often occupied elevated or defensible locations, possibly due to environmental conditions or the need to manage herd movements across rugged terrain. Southeastern European sites reveal a blend of continuity and change, with some villages exhibiting remarkable longevity through repeated rebuilding phases. These architectural and organizational patterns emerged within broader social frameworks that emphasized cooperation, shared identity, and the maintenance of household autonomy. The Copper Age did not witness the emergence of centralized political structures or rigid social hierarchies, but it did see the early development of differentiated roles within communities. These roles were shaped by craft specialization, control of certain resources, or the symbolic significance of particular households. Across these centuries, settlement patterns and social organization reflect the slow, steady evolution of communities adapting to new technological opportunities, expanding populations, and changing landscapes. The built environment became a canvas upon which households expressed both continuity with ancestral traditions and openness to gradual transformation. Within this context, the early foundations of more complex social structures quietly took shape. As Copper Age settlements continued to expand, the relationships between households, workspaces, and communal areas grew increasingly structured. Excavations reveal evidence for activity zones within villages, areas dedicated to food preparation, pottery firing, textile production, or tool manufacture. These zones were not isolated from domestic life, but woven into its rhythms, reflecting how economic and social practices overlapped in shared spaces. The presence of hearths, grinding stones, loom weights, and refuse deposits in close proximity underscores the multifunctional nature of Copper Age households. Rather than separating domestic and craft activities, communities integrated them within flexible spatial arrangements suited to seasonal and practical demands. The organization of outdoor spaces provides further insight into community life. Many settlements contained open courtyards where households gathered for tasks requiring extended space or cooperative effort. These courtyards served as locations for drying cereals, repairing tools, tending to livestock, or conducting small-scale craft activities. Their placement within settlements often reflects long-term use, with successive rebuilding phases maintaining their general positions. In some regions, evidence for well-trodden pathways indicates regular circulation between houses, fields, and pasture zones. These paths connected daily activities to broader landscapes, reinforcing the continuity between settlement interiors and their surrounding environments. Defensive structures appear infrequently during this period, yet some settlements exhibit modest boundary markers or ditches. In certain areas of southeastern Europe, shallow ditches or palisades may have served to manage livestock, delineate settlement edges, or provide limited protection during times of uncertainty. These features do not suggest large-scale conflict, but rather reflect practical responses to local conditions. Archaeologists caution against interpreting them as indicators of centralized authority or militarized organization. Instead, they reveal community-level decisions shaped by environmental and social needs. Within households, interior spaces were arranged according to function and tradition. Single-room houses remained common in many regions, though multi-room structures became more frequent as settlements grew. Some houses contained raised platforms for sleeping or storage, while others incorporated built-in benches, clay-lined bins, or plastered hearths. The interior organization of houses reflects careful attention to the sequence of daily tasks, from food preparation to craftwork to storage. In some cases, the clustering of certain tools or materials suggests that specific activities, such as weaving or pottery finishing, were practiced more intensively by particular households. These patterns provide clues to emerging specialization within communities, though specialization remained embedded within household structures rather than forming separate occupational groups. Burial traditions continued to play an important role in social organization. House floor burials or interments within settlement boundaries linked living spaces to ancestral memory. In some regions, children or infants were buried beneath house floors, while adults were interred in adjacent areas. This spatial connection reinforced generational continuity and highlighted the significance of household units as social anchors. Differential grave goods reveal nuanced expressions of identity. Simple pottery vessels, stone tools, personal ornaments, and occasional copper items mark distinctions among individuals. Archaeologists interpret these variations cautiously, recognizing that grave goods reflect cultural meaning rather than straightforward measures of wealth or status. Nonetheless, the presence of such distinctions suggests that communities acknowledge differences in role, experience, or symbolic importance. In several regions, burials outside settlements also became more common. Cemeteries located along ridge lines, near water sources, or in open fields indicate shifting attitudes toward mortuary space. These dedicated burial areas often contain clusters of grave arranged according to familial or social relationships. Differences in burial architecture, such as stone-lined pits, cairns, or simple earthen grave, reflect regional traditions rather than hierarchical organization. The diversity of mortuary practices across Copper Age regions underscores the varied ways in which communities expressed identity, memory, and belonging. As craft production continued to mature, some settlements developed localized areas of specialized activity. Pottery kilns, for example, required open space and careful fuel management, leading to their placement along settlement edges to reduce fire risk. The remains of repeated firings, ash deposits, kiln fragments, and ceramic waste accumulated in these zones, marking them as recognizable craft areas. Similar spatial patterns emerge for stone tool manufacture, where concentrations of flint flakes or groundstone fragments indicate extended periods of knapping or shaping. These zones need not represent full-time specialization, but do demonstrate how certain tasks became associated with specific locations over time. Social relations within settlements remained grounded in cooperation and shared responsibility. Households participated in collective tasks such as harvesting, building maintenance, and managing water sources. The construction of new houses often required communal labor, as did repairs to pathways, boundary markers, or shared facilities. Seasonal events, including feasting, ritual gatherings, or exchange meetings, reinforced social cohesion. Archaeological evidence from some sites, including communal hearths, large feasting vessels, or shared storage buildings, suggests that these gatherings played an important role in maintaining harmony and distributing resources among households. Regional diversity in social forms continued to shape Copper Age communities. In southeastern Europe, some settlements grew substantially and exhibited complex internal organization, hinting at early forms of social differentiation. In contrast, many Anatolian and Levantine sites maintained relatively modest scales, with households displaying few indications of pronounced hierarchy. The Caucasus presented yet another pattern, with settlements often dispersed across upland zones, reflecting pastoral mobility and strong ties to seasonal landscapes. These regional differences highlight the adaptability of Copper Age societies, which organized themselves according to local traditions, environmental conditions, and long-term historical trajectories. Despite emerging distinctions among households, most Copper Age communities retained social structures rooted in equality and mutual dependence. No strong evidence points to centralized leadership or institutionalized hierarchy during this period. Instead, authority likely rested within households or lineage groups, expressed through age, experience, ritual knowledge, or control of certain resources. These forms of leadership remained fluid and context-dependent, contributing to a social landscape in which cooperation remained essential. By the close of the 4th millennium BCE, settlement patterns and social organization across the Copper Age world had achieved a delicate balance between continuity and transformation. Communities lived within increasingly structured built environments, maintained long-standing domestic routines, and participated in social networks shaped by cooperation and shared identity. Architectural layouts, burial customs, and craft zones all reflected the gradual refinement of daily life. These developments marked an era in which settlements became more cohesive, households more differentiated, and social practices more varied, yet all within frameworks that preserved stability and collective resilience. The chapter rests here, within the evolving shapes of houses, pathways, communal spaces, and social bonds that defined Copper Age settlement life and set the stage for further transformation in the centuries to come. Across the Copper Age world, between roughly 4500 and 3000 BCE, communities continued to cultivate symbolic systems that had their origins in earlier Neolithic traditions. These systems were expressed through figurines, decorated ceramics, carved stone objects, and the construction of dedicated ritual spaces. Archaeological evidence shows that symbolic life remained deeply integrated into daily routines, household practices, and community gatherings. Rather than forming a sharply distinct sphere, ritual activity existed within the same landscapes, architectural settings, and temporal rhythms that structured subsistence and social life. In this context, early metallurgy did not emerge as an isolated technological innovation, but developed within cultural environments shaped by long-standing beliefs and shared symbolic understandings. Figurines provide some of the most visible evidence of symbolic continuity. These small crafted objects, made of clay, stone, bone, or occasionally metal, appear across a wide range of Copper Age sites. Their forms vary considerably, reflecting regional styles and cultural preferences. In southeastern Europe, anthropomorphic figurines often feature stylized bodies with emphasized torsos or limbs, while in parts of Anatolia, more abstract forms prevail. Some figurines depict animals, perhaps symbolizing herd protection, seasonal cycles, or roles within the broader cosmological framework. Although their specific meanings remain uncertain, the persistence of figurine production across centuries suggests that communities maintained shared symbolic practices rooted in earlier Neolithic traditions. Decorated ceramics also played a significant role in expressing cultural identity. Households produced vessels with painted, incised, or molded designs that reflected regional motifs and long-standing stylistic conventions. These decorations often combined geometric patterns, flowing lines, and symbolic shapes that held cultural significance. While many vessels served utilitarian purposes, their visual designs carried communicative value, linking everyday objects to broader systems of belief. In some regions, specific vessel shapes or motifs appear in ritual contexts, indicating that pottery held ceremonial importance beyond its practical uses. The refinement of ceramic decoration during this period demonstrates the value placed on aesthetic expression and symbolic continuity. Carved stone objects represent another facet of Copper Age symbolic life. These objects, which include mace heads, figurines, plaques, and decorated tools, required considerable effort to produce. Their craftsmanship suggests that they held meaning beyond simple utility. In several regions, carved stone items appear in ritual deposits, burials, or shrine spaces, indicating that they may have played roles in ceremonial activities. Animal motifs, geometric patterns, and abstract designs reflect cultural narratives or symbolic associations that remain partly obscured but nonetheless reveal continuity with earlier Neolithic imagery. Ritual spaces varied widely across the Copper Age world, reflecting differences in local traditions, settlement organization, and environmental context. In some settlements, excavators have identified small rooms or structures interpreted as shrines, often containing clay figurines, decorated vessels, or symbolic installations such as altars or plastered platforms. These spaces are typically modest in scale, suggesting that ritual activities were conducted within household or neighborhood contexts rather than under centralized authority. Their placement within settlements demonstrates that ritual life remained closely tied to domestic routines, reinforcing social cohesion through shared practices grounded in familiar surroundings. In other regions, communal ritual areas appear outside individual households. Some villages feature open-air spaces used for gatherings, feasts, or seasonal ceremonies. These spaces may have been marked by distinctive arrangements of stones, elevated platforms, or concentrations of symbolic objects. Their use likely changed across seasons, aligning with agricultural cycles or social rhythms. Such communal gathering places played an important role in maintaining group identity, reinforcing bonds among households, and coordinating shared obligations. The integration of ritual spaces into the broader settlement landscape reflects the continuity of cultural practices that had been developing since the Neolithic. Deposition practices provide further insight into symbolic expression. Communities deposited objects, figurines, vessels, tools, or ornaments within pits, beneath floors, or along settlement boundaries. These deposits were deliberate and structured, reflecting practices associated with renewal, protection, or commemoration. In some cases, deposition occurred during the construction or abandonment of houses, suggesting symbolic meanings linked to household continuity or transition. In others, objects were placed in communal areas or at the edges of settlements, marking spatial thresholds or reinforcing certain cultural boundaries. These practices varied regionally, but share underlying themes of ritual engagement with the built environment. Ritual gatherings played a central role in cultural life. These events may have involved collective meals, the sharing of symbolic items, or the performance of ceremonies linked to seasonal cycles, harvests, or communal obligations. Archaeologists infer these gatherings from the presence of large serving vessels, clusters of decorated ceramics, or concentrations of animal remains within specific contexts. These events strengthened social cohesion by bringing households together, reasserting shared identities, and renewing ties through collective participation. The symbolic significance of such gatherings lay not only in the objects used, but in the coordinated activities that reaffirmed community cohesion. Regional variation remained a defining feature of symbolic life during this era. Communities in southeastern Europe maintained traditions emphasizing figurines and decorated ceramics, while groups in Anatolia engaged in architectural expressions of ritual, including plastered installations or designated shrine rooms. In the Near East, symbolic practices often incorporated long-standing traditions of ancestor veneration, storage rituals, or ceremonial feasting. These variations demonstrate that Copper Age symbolic systems were not uniform, but shaped by local histories, environmental contexts, and cultural lineages. Nonetheless, despite their diversity, these systems reveal broad continuity with earlier practices, suggesting that communities viewed the introduction of new technologies, such as early metallurgy, through the lens of established symbolic frameworks. Throughout this period, symbolic expression remained closely tied to everyday life. Ritual and domestic activities were not sharply distinguished, but coexisted within the same spaces, tools, and materials. Figurines rested alongside household implements. Decorated vessels held both food and symbolic meaning. Carved stone objects circulated within both practical and ceremonial contexts. This integration reveals that Copper Age belief systems were not confined to particular structures or moments, but infused daily routines with cultural significance. As Copper Age communities continued to refine their symbolic traditions, the placement and treatment of ritual objects became increasingly intertwined with broader social practices. Many settlements show evidence of structured deposits, carefully arranged assemblages of figurines, pottery, tools, or animal remains placed in pits, beneath building floors, or along settlement margins. These deposits were neither random nor utilitarian in purpose. Their deliberate placement suggests acts of dedication, closure, protection, or renewal associated with the life cycles of households and communal spaces. Although the specific meanings of these deposits remain a topic of scholarly discussion, their patterned occurrence underscores the central role of symbolic action in shaping how communities understood place, continuity, and transformation. Architectural settings for ritual practices reveal notable diversity. In some regions, such as parts of the Balkans and Anatolia, small rooms within domestic structures exhibit features suggesting specialized ritual use. These spaces sometimes contain altars, benches, plaster installations, or concentrations of symbolic objects. Their modest scale indicates that ritual activity occurred as part of daily household routines rather than through centralized ceremonial institutions. The intimate placement of these spaces within dwellings suggests that families or small social groups maintained their own ritual traditions, likely tied to concerns such as household prosperity, protection, or ancestral memory. Elsewhere, ritual activity occupied semi-public or community-shared areas. Open courtyards or designated outdoor zones contain evidence of gatherings, feasting, or ceremonial deposition. Large ceramic vessels, concentrations of animal bones, and decorated objects found in these areas point to events that brought multiple households together. Such gatherings fostered cohesion, reinforced shared identities, and allowed the renewal of social bonds. The seasonal nature of agriculture and herding likely influenced the timing of these rituals. Periods following harvests, herd movements, or building cycles provided natural opportunities for collective participation in symbolic activities. Ritual practices also extended to shaping the landscape beyond settlement boundaries. Cairns, stone arrangements, or small constructed features located near water sources, hillsea. Des or pathways suggest symbolic engagement with the wider environment. These features may have marked significant locations, served as places of offering, or represented focal points for seasonal observance. Their placement indicates that symbolic worlds were not confined to the settlement interior, but encompassed the broader terrain through which communities moved, grazed their herds, and gathered resources. This integration reflects a worldview that connected social life to land, seasonality, and long-term continuity. Burial customs provide another important dimension of Copper Age symbolic expression. Although practices varied across regions, many communities continued traditions inherited from earlier periods, placing the dead within or near settlements. These burials often contained modest grave goods, pottery, beads, stone tools, or occasionally copper items. Their arrangement suggests care and intentionality, with bodies placed in flexed positions, side-lying orientations, or specific alignments. These practices likely conveyed attitudes toward ancestry, memory, and the cyclical nature of life. Variability in grave goods reveals subtle distinctions among individuals or households, though such distinctions appear more symbolic than hierarchical during this period. In some areas, cemeteries began to develop outside settlement boundaries. These extramural burial grounds represent a shift in the spatial organization of ritual life, suggesting that communities began to separate spaces for the living and spaces for the dead more clearly. The reasons for this shift remains subject to scholarly interpretation. Some researchers suggest growing settlement density encouraged the establishment of designated burial areas, while others propose changes in ritual ideology. Regardless of the cause, these cemeteries continued to reflect long-standing symbolic practices, including grave offerings and the careful arrangement of bodies. Symbolic artifacts played important roles in reinforcing cultural identity. Painted motifs on ceramics often echoed themes found in figurines or carved stone objects, forming a coherent visual language across different material forms. This coherence suggests the presence of shared cultural narratives expressed through multiple media. Certain motifs, spirals, crosshatches, stylized animals, or abstract shapes, appear repeatedly within specific regions, highlighting continuity in symbolic practice even as settlement structures and economic systems evolved. Early metal objects also entered symbolic domains during this period. Although copper remained limited in availability and primarily used for small tools, its distinctive appearance and malleability made it suitable for personal ornaments or ritual deposition. Some grave contain copper beads or pins positioned near the hands or chest, indicating their role as markers of identity or symbolic value. In certain ritual contexts, copper objects appear alongside traditional Neolithic materials such as stone or clay, demonstrating that metallurgy was incorporated into existing symbolic frameworks rather than replacing earlier traditions. This integration underscores the continuity of belief systems as communities adopted new materials within familiar cultural structures. Feasting traditions represent another aspect of Copper Age symbolic life. Archaeological deposits containing large quantities of animal bones, oversized ceramic vessels, and evidence of communal preparation suggest that shared meals played an important role in reinforcing social relationships. Feasting events likely occurred during seasonal transitions, ritual gatherings, or collective building projects. These gatherings offered opportunities to reaffirm social ties, express shared values, and redistribute resources within the community. The significance of feasting extended beyond sustenance. It represented a symbolic reaffirmation of unity and cooperation. Regional identities shaped the specific forms of symbolic expression. In the Near East, communities maintained strong ties to long-standing traditions of ancestor veneration and household ritual. In the Caucasus, symbolic practices often incorporated elements reflecting pastoral mobility, with objects and installations linked to herding cycles and seasonal movement. Southeastern Europe continued to emphasize figurines and decorated ceramics as core expressions of cultural identity. This diversity demonstrates that Copper Age symbolic life cannot be understood as a single system, but as a constellation of practices rooted in regional histories and adapted to local environments. Despite these regional variations, the broader pattern reveals remarkable continuity with earlier symbolic worlds. Copper Age communities did not abandon Neolithic beliefs in favor of new forms, but adapted them gradually, integrating new materials and practices within familiar frameworks. Ritual activity remained embedded in daily life, shaping how households understood their relationships to the land, to each other, and to their ancestors. Symbolic expression thus provided cultural stability during a period of gradual technological change, supporting the integration of early metallurgy into long-standing systems of meaning. By the close of this era, ritual traditions and symbolic practices had become deeply interwoven with the economic and social structures of Copper Age societies. Figurines, decorated ceramics, carved stone objects, and early metal ornaments circulated within households, shrines, and communal spaces, reinforcing shared identities and linking communities to their ancestral pasts. These enduring practices formed a cultural foundation that supported both continuity and gradual transformation, enabling Copper Age societies to navigate technological change within stable symbolic frameworks. The chapter settles here, among the ritual spaces, crafted symbols, and shared cultural practices that shaped the spiritual and social life of Copper Age communities and grounded their technological developments in deep-rooted traditions. Across the centuries, between roughly 4500 and 3000 BCE, communities in southeastern Europe, the Near East, and the Caucasus became increasingly interconnected through networks of exchange, seasonal movement, and shared technological traditions. These networks did not arise suddenly. They developed gradually through long-standing patterns of mobility, reciprocity, and interaction that had shaped earlier Neolithic societies. During the Copper Age, however, the scale and complexity of these interactions expanded, allowing materials, ideas, and emerging technologies, most notably early forms of metallurgy, to circulate across wide geographic areas. Archaeological evidence from settlements, burial grounds, and production sites illustrates how these connections influenced economic activity, social organization, and patterns of settlement. The movement of obsidian provides one of the clearest indicators of long-distance interaction. Obsidian, valued for its sharp edges and durable qualities, originated from specific volcanic sources in regions such as central Anatolia, the Caucasus, and the Aegean. Yet obsidian artifacts appear in Copper Age settlements located hundreds of kilometers from these sources. The presence of obsidian blades, flakes, and tools demonstrates that communities participated in established exchange routes that transmitted not only raw materials, but also knowledge of tool-making techniques. These networks connected inland villages to coastal settlements, upland communities to river valleys, and small hamlets to larger regional centers. Shell ornaments offer another important line of evidence for interregional interaction. Marine shells found far inland, often shaped into beads, pendants, or small decorative items, indicate that communities valued these materials for their visual qualities and symbolic associations. The movement of shells suggests the existence of trade pathways linking Mediterranean, Black Sea, and even Red Sea coastlines to inland regions. These ornaments often appear in burial contexts or ritual deposits, highlighting their cultural significance within households and communities. Their distribution reveals the wide reach of exchange networks that extended well beyond immediate ecological zones. Pottery styles also circulated along these networks, providing insight into the movement of ideas and aesthetic traditions. Distinctive ceramic forms, motifs, or surface treatments spread gradually across regions, sometimes adapting to local preferences while retaining recognizable stylistic elements. The diffusion of these ceramic traditions demonstrates how communities observed, imitated, and modified designs encountered through trade or social gatherings. This movement of styles does not imply large-scale migration, but rather indicates ongoing communication between groups, facilitated by periodic interaction at shared meeting points or along established travel routes. Early metal objects, beads, awls, pins, and small blades played a growing role in exchange during this period. In regions where copper ore was scarce, metal items appeared as imported goods, signaling that metallurgy had become integrated into broader systems of distribution. Communities without access to ore sources likely acquired these objects through reciprocal exchange, social alliances, or participation in seasonal gatherings. The movement of metal objects helped introduce new technological possibilities to regions otherwise insulated from direct metallurgical experimentation. Even where metalworking remained rare, the presence of copper items signaled their emerging value within social and symbolic systems. In several regions, the emergence of specialized producers contributed to the diversification of exchange networks. Potters, stoneworkers, and early metalworkers developed skills that allowed them to produce goods of consistent quality, making their products desirable to neighboring communities. These specialists often operated within household settings, but their proficiency enabled them to participate more directly in regional exchange. Archaeological evidence from southeastern Europe, for example, indicates that certain settlements produced distinctive pottery or metal items that circulated widely. The development of specialized roles reflects not only growing technical expertise, but also the increasing interdependence of Copper Age settlements. Copper ingots and partially worked metal pieces represent another important aspect of early exchange. Although large-scale mining and smelting remained limited during this period, communities with access to ore sources occasionally produced small ingots or rough metal lumps suitable for transport. These items could be traded to regions lacking ore, where local craftspeople might rework them into finished objects. The circulation of ingots reveals an emerging awareness of metal as a raw material with transferable value, distinct from finished tools or ornaments. This development marks a significant step toward more structured metallurgical economies that would characterize later periods. Alongside these peaceful forms of interaction, archaeological evidence points to episodes of tension and conflict. Some settlements constructed modest defensive features, such as ditches, palisades, or stone walls, suggesting concerns over security. These structures likely served multiple functions, not only protection, but also the management of livestock or the delineation of settlement boundaries. Interpretations of these features must be cautious. Their presence does not necessarily indicate sustained warfare, but they do suggest that communities occasionally faced threats or uncertainty. Skeletal remains from certain regions provide more direct evidence of interpersonal violence. Injuries consistent with blunt force trauma, projectile wounds, or defensive fractures appear in some burial populations. These findings indicate that conflict, whether between neighboring groups or within communities, was a part of Copper Age life. The causes of such conflicts remain speculative. Competition over grazing land, disputes arising from resource scarcity, or tensions related to increased mobility and interaction. Regardless of the causes, the presence of trauma highlights the social complexity of the period, reflecting both cooperation through exchange and conflict arising from localized pressures. Shifts in settlement placement also point to concerns about security. Some communities relocated to more defensible positions, hilltops, ridges, or areas with wide visibility. These locations offered natural advantages for monitoring movement across landscapes and responding to potential threats. Such shifts were not universal, and many settlements remained in open, fertile plains. Nonetheless, the emergence of more defensible sites demonstrates that certain communities adapted their settlement strategies in response to regional conditions. Despite these episodes of conflict, the broader pattern reveals increasing interdependence across Copper Age regions. Exchange networks facilitated access to materials unavailable locally, supported technological innovation, and reinforced social ties. Communities interacted through reciprocal relationships rather than hierarchical or centralized systems, reflecting the decentralized nature of Copper Age social organization. These interactions laid the groundwork for the more complex trade systems that would characterize subsequent periods. Within this interconnected world, daily life unfolded against a backdrop of both continuity and change. The movement of materials and ideas supported gradual technological development, while localized tensions prompted adaptations in settlement structure and social practice. Through these processes, Copper Age societies became increasingly enmeshed in networks that shaped their economic, social, and symbolic horizons. As exchange networks strengthened across the Copper Age world, the circulation of goods fostered not only economic interaction, but also the transmission of knowledge. Communities encountering new materials or unfamiliar technologies often adapted them to local traditions, resulting in gradual innovation rather than abrupt transformation. Techniques of pottery production, stone tool manufacture, textile processing, and early metalworking spread through indirect observation, imitation, and small-scale experimentation. These interactions highlight the significance of social contact in shaping technological development, even when communities maintained distinct cultural identities. Travel routes played a crucial role in sustaining these networks. River valleys, mountain passes, and coastal corridors formed natural pathways that guided movement across regions. In southeastern Europe, the Danube and its tributaries connected inland settlements to the Black Sea, facilitating the movement of stone, pottery, and early metal goods. In Anatolia, Well-worn paths linked highland zones to lowland plains, allowing herding groups and farmers to meet at seasonal gatherings. The Caucasus, with its varied terrain, featured routes that crossed foothills and uplands, linking small communities situated in diverse ecological zones. These routes were not formalized roads, but rather centuries-old tracks created through repeated passage, reflecting deep familiarity with surrounding landscapes. Exchange was rarely a purely transactional process. It was embedded in the social fabric of gatherings, feasts, and periodic meetings that reinforced relationships between communities. Archaeological evidence for these gatherings includes concentrations of decorated ceramics, large serving vessels, and animal remains associated with shared meals. These events offered opportunities to exchange goods, reaffirm alliances, and negotiate seasonal responsibilities. They also allowed for the spread of ideas, as participants observed new objects, encountered unfamiliar techniques, and returned home with materials or knowledge that could be integrated into local practices. Through these interactions, regional cultures maintained distinct identities while participating in broader networks of mutual influence. Copper objects played an increasingly significant role in these gatherings. Their visual qualities, color, sheen, and malleability distinguished them from stone or bone tools. As communities encountered copper items through exchange, they began to incorporate them into personal adornment, ritual deposits, or specialized tasks. Even in regions where copperworking remained limited, imported items informed local understandings of metal's properties. The movement of metal objects thus contributed to the slow diffusion of metallurgical knowledge, complementing the more established exchange of stone and ceramic goods. As exchange intensified, certain settlements developed roles as regional nodes. These sites often displayed evidence of craft specialization, storage capacity, or strategic placement along major interaction routes. Archaeologists identify such nodes through concentrations of non-local materials, dense occupation layers, or signs of repeated rebuilding. These settlements did not function as political centers in the later sense, but acted as focal points for local networks, facilitating the movement of goods and people. Their emergence reflects the growing complexity of Copper Age interaction systems and the increasing interdependence among communities. Not all interactions were peaceful. Evidence for conflict appears in several archaeological contexts, revealing that tensions occasionally disrupted the fabric of regional connectivity. Defensive structures, once limited to modest boundary markers, became more substantial in some regions. Palisades, ditches, and simple walls appear at settlement perimeters, sometimes accompanied by signs of rapid reconstruction or damage. These features likely served multiple purposes, managing livestock, delineating village boundaries, or responding to external threats, but their presence indicates an awareness of vulnerability. Skeletal evidence further illuminates the presence of conflict. Some burial populations show injuries consistent with interpersonal violence, including cranial fractures, projectile wounds, and defensive injuries to the forearms. These patterns do not suggest widespread warfare, but point to localized disputes, raiding, or episodic clashes among neighboring groups. The causes of violence remain uncertain, though competition for grazing land, water sources, or trade routes may have contributed. Environmental fluctuations may also have played a role by influencing resource availability in certain years, prompting disputes between closely situated communities. Settlement shifts also provide insight into conflict dynamics. In some areas, villages were relocated from open plains to more defensible hilltops or elevated ridges. These moves reflect changing priorities, emphasizing security or visibility over easy access to farmland. Although not all settlements adopted these positions, the existence of defensible locations suggests a need to monitor movement across landscapes or to defend stored resources during periods of tension. Over time, these elevated settlements became characteristic features of certain regional landscapes, linking environmental adaptation to social concerns. Despite these instances of conflict, the broader pattern reveals the resilience of exchange networks. Even as communities built defensive features or relocated their settlements, Interactions continued across regional and ecological boundaries. Trade routes remained active, ceramic styles continued to spread, and obsidian and copper objects moved along established pathways. These patterns highlight the intricate balance between cooperation and competition that shaped Copper Age societies. Interaction allowed communities to secure needed resources, while occasional tension prompted adaptations that influenced settlement placement and social organization. The long-term significance of these networks lies in their cumulative effects. Through repeated exchanges, communities developed broader horizons of awareness, encountering materials and techniques that they might not have discovered independently. Social relationships formed through gatherings and reciprocal exchange created enduring ties across regions. Even conflict contributed to these developments by shaping settlement patterns and prompting innovations in defensive strategies. Together, these factors produced a landscape of interconnected communities that relied on one another for resources, knowledge, and occasional protection. By the end of the 3rd millennium BCE, these interconnected regions had developed complex webs of interaction that supported the circulation of goods and ideas across long distances. The Copper Age world had become one in which communities were linked through shared practices, mutual dependence, and periodic tension. These connections formed the foundation upon which later, more formalized trade systems would be built. The chapter rests here, among the pathways, exchanges, and shifting boundaries that shaped Copper Age interaction and contributed to the gradual emergence of more interconnected and dynamic societies. Between approximately 3500 and 3000 BCE, communities across southeastern Europe, Anatolia, the Caucasus, and the Near East entered a phase in which emerging metallurgical traditions became increasingly structured. The modest experimentation of earlier centuries gradually gave way to more organized production practices, supported by improvements in smelting techniques, more reliable access to ore sources, and the expansion of craft knowledge within and between settlements. These developments did not unfold uniformly across regions, nor did they signal a complete departure from earlier technologies. Instead, they represent a gradual consolidation of skills, materials, and social arrangements that allowed metallurgy to take a more prominent place within Copper Age economies. As metal production grew more consistent, the spatial organization of it began to change. Earlier metallurgical activities were small in scale and often conducted within domestic contexts, but during this period, several regions show evidence for more defined workshop spaces. These workshops were modest in size, yet distinct in layout and placement. Archaeologists identify areas with concentrations of slag, furnace fragments, crucible pieces, hammerstones, and molds, indicating zones dedicated to repeated metallurgical activity. Although many of these spaces remained within settlements rather than separate industrial districts, their clustering suggests a more regularized approach to production. Advances in casting techniques also appear during this era. While cold hammering and simple annealing remained widespread, communities began experimenting more confidently with casting molten metal. The presence of stone or clay molds, occasionally found in pairs to form two-part casting systems, reflects this growing proficiency. These molds often produced small items, flat axes, chisels, awls, and symbolic objects, suggesting that early casting served both functional and ceremonial purposes. Although copper's softness limited its utility for heavy labor tools, cast objects demonstrated greater technological control and allowed craftspeople to replicate shapes more consistently. Technological developments were closely tied to improvements in resource access. Communities with reliable sources of ore began to increase their production capacity, while those without local deposits deepened their participation in exchange networks to obtain raw materials. Mining activity in some regions intensified, though still on a small scale by later standards. Shallow pits, trench-like extractions, and evidence of ore selection near exposed deposits indicate that communities were increasingly systematic in gathering minerals. These efforts required coordinated labor, careful organization, and knowledge of geological features, skills that spread gradually as metallurgical demand increased. The emergence of specialized labor represents one of the most notable transformations of this period. Although households continued to produce many of their daily necessities, the growing complexity of metallurgical processes encouraged the development of individuals or small groups who possessed greater expertise. These specialists likely learned through practical apprenticeship, observing and refining techniques over many years. Their skills included ore selection, smelting, alloy experimentation where present, mold preparation, and finishing work using hammering or polishing tools. While specialization did not necessarily confer high GH status in a formal sense, it contributed to subtle distinctions within communities, reflecting an ongoing diversification of roles. Ceremonial metal objects highlight the symbolic dimensions of technological change. In several regions, metal items appear in burial contexts or ritual deposits, where their polished surfaces and distinctive color carried cultural meaning. Some of these objects, ornaments, pins, small blades, were crafted with greater care than utilitarian tools, suggesting that communities recognized metal's potential as a material of symbolic expression. Their placement within ritual settings indicates that metal had become embedded in cultural narratives associated with identity, ancestry, or communal memory. These practices strengthened the connection between metallurgy and social meaning, supporting its continued expansion within daily and ceremonial life. As technological systems became more structured, social differentiation began to appear more clearly in settlement layouts and household inventories. In some regions, larger or more elaborately built houses contained distinct sets of tools, pottery types, or symbolic objects that suggest privileged access to certain resources. These differences were not uniform or sharply hierarchical, yet they indicate that households began to diverge in their economic activities and social roles. Access to metalworking knowledge, control of specialized goods, or participation in long-distance exchange likely contributed to these emerging distinctions. The presence of larger communal buildings or designated gathering spaces in certain settlements reinforces the idea that social organization was becoming increasingly layered. Settlement hierarchies also became more visible. Some sites expanded significantly, developing more complex internal organization and functioning as regional centers within wider networks. These settlements exhibited dense occupation layers, evidence of specialized production, and well-defined neighborhoods or activity zones. Smaller satellite settlements or seasonal camps clustered around these centers, connected through paths, exchange systems, and shared cultural practices. This pattern suggests the early stages of regional integration, in which communities participated in broader social and economic spheres without relinquishing local autonomy. Trade systems continued to grow in reach and complexity during this period, facilitating the movement of copper ingots, finished objects, pottery, textiles, and symbolic items. Routes followed river valleys, coastal margins, and mountain passes, linking ore-rich regions to agricultural zones and pastoral landscapes. The expanded circulation of goods not only supported technological development, but also played a role in shaping social identity. Communities recognized themselves as part of wider networks in which materials and ideas flowed across distances. This recognition contributed to the slow emergence of regional cultural spheres defined by shared practices and stylistic preferences. Through these interrelated developments, workshop organization, casting techniques, resource access, labor specialization, and growing settlement hierarchy, metallurgy began to exert a more direct influence on social life. It did not yet dominate economies or displace older craft traditions, but its presence contributed to a gradual shift in how communities structured their activities, exchanged goods, and perceived social distinctions. The consolidation of technological knowledge during this era provided the foundation upon which later Bronze Age innovations would build, transforming small-scale copper production into more complex metallurgical systems. As metallurgical knowledge deepened, the organization of labor within settlements became more defined. While most households continued to engage in a broad range of productive activities, the growing complexity of metalworking encouraged a gradual concentration of skill among certain individuals. These craftspeople required familiarity with ore quality, furnace construction, fuel selection, and temperature control skills that were not easily acquired without repeated practice. The presence of distinct workshop areas within some settlements suggests that metalworking activities were increasingly separated from routine domestic tasks, though they remained embedded within local social structures rather than forming independent professional classes. The emergence of such specialized knowledge contributed to the differentiation of roles within communities, marking an important step in the development of more complex social systems. In parallel with the rise of specialized labor, the organization of production became more efficient. Ore was processed in batches, with smelting episodes likely timed to coincide with periods of surplus labor, such as after harvests or during seasons when pastoral demands were low. Communities learned to select suitable fuels, often specific types of wood or charcoal, that allowed furnaces to reach higher temperatures with greater consistency. The refinement of furnace design, including improved insulation and airflow control, facilitated more predictable smelting outcomes. These developments reduced the inefficiencies characteristic of earlier metallurgical experimentation and laid the groundwork for more sustained production efforts. The growing consistency of metal production contributed to the expansion of tool repertoires. In addition to simple awls and beads, communities began producing flat axes, chisels, and small blades that offered improved durability or sharpness when properly shaped and polished. While copper's softness limited its effectiveness for demanding tasks such as felling large trees, it suited finer woodworking, leather preparation, and certain agricultural activities. Metal tools supplemented rather than replaced stone implements, but their reliability offered new possibilities for craftspeople and household producers. Their presence also reinforced the value of metallurgical knowledge within communities, further elevating the importance of individuals skilled in metalworking. Ceremonial metal objects continued to reflect the symbolic dimensions of technological change. Carefully crafted pins, pendants, and small iconographic items often appear in burial contexts, where they served as markers of identity or indicators of affiliation with particular households or groups. These objects may have represented social roles, achievements, or connections to lineage traditions, though interpretations remain tentative. Their inclusion in burials underscores the social meaning attributed to metal, which extended beyond practical utility. In some regions, the appearance of metal objects alongside finely made ceramics or carved stone items suggests that households used material culture to express distinctions that had begun to emerge within increasingly interconnected social landscapes. These shifts in production and symbolism coincided with broader changes in settlement organization. Larger settlements developed more stratified internal structures, with neighborhoods or household clusters exhibiting distinct craft activities or access to specialized goods. In southeastern Europe and parts of Anatolia, archaeological evidence points to settlements with sizable communal buildings, designated storage facilities, or defined workshop zones. These features signal the increasing complexity of community coordination and resource management. Although leadership structures remain difficult to identify, the organization of space suggests shared decision-making and collective effort in managing production, distribution, and ceremonial activities. The growing interdependence of settlements during this period reflects the broader regionalization of Copper Age societies. Larger sites began to serve as central places within wider networks, receiving goods from smaller satellite communities and distributing specialized items, including metal tools and ornaments. These centers did not exert political control in a formal sense, but their strategic positions along exchange routes enabled them to shape the flow of materials and information. Their role as focal points contributed to subtle shifts in regional identity, as shared practices, stylistic traditions, and technological norms spread outward along established pathways. The expansion of trade networks played a crucial role in supporting technological consolidation. Communities with access to ore sources supplied ingots or semi-processed metal to regions lacking mineral resources, while agricultural settlements provided surplus grain, livestock products, or textiles in return. This reciprocal system strengthened economic interdependence and allowed metallurgy to expand beyond its original geographic origins. Trade routes that had long transmitted obsidian, shell ornaments, and pottery designs now carried copper items, creating ever wider horizons of technological and cultural connection. Amid this growing connectivity, some regions experienced increases in defensive installations or settlement fortifications. Although conflict remained uneven and localized, the emergence of more structured technologies, including metallurgy, may have contributed to competition over access to resources or trade routes. Defensive features such as ditches, walls, and elevated settlement locations reflect practical responses to perceived threats. These constructions were not evidence of centralized warfare, but rather adaptations within decentralized societies navigating complex landscapes of cooperation and rivalry. Such features also suggest that as settlements grew more complex, safeguarding stored goods, workshop areas, or communal facilities became a priority. The combined developments of this period, specialized labor, structured production, expanded tool repertoires, evolving symbolic practices, and increase in articulated settlement hierarchies represent an important stage in the broader transformation of Copper Age societies. Metallurgy did not yet dominate social or economic life, but its growing influence intersected with other technological and social changes, reinforcing patterns of differentiation and integration. These changes occurred gradually, shaped by local conditions and long-standing traditions rather than sudden innovation or external imposition. By the close of the 3rd millennium BCE, Copper Age communities had developed systems capable of sustaining regular metallurgical production and supporting more complex social structures. These systems remained fundamentally grounded in earlier practices, but they incorporated new forms of expertise, organization, and interaction that set the stage for future developments. The world that emerged from this period was one in which metal had become an increasingly familiar and valued material, and in which the foundations of later Bronze Age transformations had been quietly laid. The chapter settles here, amid the growing patterns of technological organization and social differentiation that reshaped Copper Age lifeways and prepared communities for the next phase of metallurgical and cultural evolution. Across the late 4th to early 3rd millennia BCE, communities in southeastern Europe, Anatolia, the Caucasus, and the Near East experienced a series of gradual yet consequential transitions. These changes marked the end of distinct Copper Age traditions and the beginning of new technological and social configurations that would characterize the emerging Bronze Age. The processes that shaped this transition unfolded unevenly, shaped by regional environments, resource availability, and long-established cultural practices. Rather than signaling abrupt rupture, this era reflects the culmination of centuries of adaptation, experimentation, and interaction. One of the most significant developments of this period was the increasing use of alloyed bronze. Metallurgists in several regions began to combine copper with tin or arsenic, producing tools and weapons that were harder, more durable, and more versatile than those made from pure copper. The adoption of bronze did not occur uniformly. Some regions with early access to tin or arsenic-bearing ores advanced more quickly, while others continued to rely on copper tools for longer. Nonetheless, the growing recognition that alloying improved metal quality signaled an important technological shift. These advancements rested upon the metallurgical knowledge accumulated during earlier centuries, building upon established smelting techniques, fuel management, and workshop organization. As metallurgy expanded, trade systems were reorganized to meet new demands. The acquisition of tin, rare and geographically limited, required the development of longer-distance networks than those previously used for copper alone. Communities began to participate in wider spheres of contact, linking mineral-rich regions to areas where metal production and consumption were concentrated. These routes overlapped with older pathways that had long transmitted obsidian, shells, pottery, and agropastoral goods, but their extension reflects shifting economic priorities. The movement of bronze objects and the ores necessary to create them connected communities across greater distances, encouraging new forms of regional interdependence. Climatic fluctuations during this period further influenced settlement patterns and economic strategies. Paleoclimatic data suggest that several regions experienced episodes of aridity or shifts in rainfall distribution during the late 4th millennium BCE. These changes may have placed pressure on agricultural systems, prompting communities to adjust planting schedules, diversify crops, or relocate to areas with more reliable water sources. In some regions, settlements moved from open plains into more defensible or elevated positions, reflecting not only environmental considerations, but also concerns related to security or the protection of stored resources. These relocations reveal how communities balanced long-standing subsistence strategies with the need to respond to changing environmental conditions. Demographic patterns also shifted during this era. Some settlements expanded significantly, becoming focal points for regional populations. Others were abandoned, replaced by new sites located along more strategic routes or near resource-rich areas. Archaeological evidence indicates that settlement clustering increased in certain regions, suggesting greater integration among neighboring communities. These clusters supported shared production efforts, coordinated subsistence strategies, and more structured systems of exchange. The development of these multi-settlement networks reflects an emerging complexity that would become characteristic of the Bronze Age. Social organization likewise underwent gradual transformatio. In earlier Copper Age distinctions, based on household roles, craft specialization, or symbolic practices, became more pronounced as communities integrated into wider economic spheres. Certain individuals or groups who controlled access to metal, trade routes, or specialized production gained increased influence within settlements. Although clear evidence for centralized authority remains limited during this transitional phase, some settlements exhibit architectural features that suggest more formal leadership structures. Larger communal buildings, fortified zones, and designated storage facilities reveal a growing need for coordination in managing resources, production, and defense. Ritual and symbolic traditions adapted as well. While Copper Age communities had maintained close continuity with Neolithic symbolic systems, the transition into the Bronze Age brought new forms of expression linked to expanded interaction networks and evolving social identities. Metal objects, once rare and primarily symbolic, became increasingly integrated into ritual practice. Burial customs shifted in some regions, with larger or more structured cemeteries emerging alongside more elaborate grave goods. These changes reflect evolving relationships between material culture and social identity, shaped by technological developments and broader cultural integration. Despite these transitions, many communities retained localized practices deeply rooted in earlier traditions. Agricultural routines, household-based craft production, and settlement layouts often continued to reflect long-standing patterns. In upland or peripheral regions, where access to alloying materials was limited or where exchange networks remained local, Copper Age traditions persisted well into the early Bronze Age. These areas demonstrate that the transition was not uniform, but involved a complex interplay between innovation and continuity. Communities adopted new technologies at different rates, adjusting them to local needs and environmental conditions. In regions where integration into wider trade systems progressed more rapidly, the influence of metallurgy became increasingly visible. Workshops produced larger numbers of tools and ornaments, and new casting techniques supported more standardized production. These developments encouraged more formalized roles for craftspeople and structured relationships between settlements. Trade routes became more firmly established, linking highland mining zones to lowland agricultural centers and coastal exchange hubs. As goods moved across these networks, metal objects, ceramic styles, Agricultural surplus. Cultural practices increasingly converged across regions. Through these interconnected changes, technological, environmental, demographic, and social, the Copper Age reached its concluding phase. Communities navigated these developments through incremental adjustments, guided by traditions that had shaped life across centuries. The transition into the Bronze Age was not a rupture, but an accumulation of shifts that gradually reoriented societies toward new forms of production, exchange, and organization. As communities moved deeper into the early 3rd millennium BCE, the cumulative effects of technological consolidation, shifting trade networks, and changing settlement patterns became more visible in the archaeological record. These developments reflect not the disappearance of Copper Age traditions, but their gradual integration into systems that would define the Bronze Age. In many regions, this integration occurred through processes that balanced innovation with continuity, allowing households and communities to adopt new technologies within familiar social frameworks. One of the most notable developments of this period was the increasing standardization of metal tools and ornaments. Earlier copper objects had varied widely in form and quality, reflecting the experimental nature of early metallurgy. As knowledge spread and production became more organized, tool types became more uniform across regions. Casting techniques improved, allowing craftspeople to produce tools with consistent shapes and more predictable performance. Flat axes, chisels, tanged blades, and small daggers reflect the growing regularity of production methods. These standardized forms suggest clearer knowledge transmission between metallurgical centers and the communities they supplied. Alloying copper with tin or arsenic further contributed to this shift. Bronze tools were stronger and more resistant to wear than pure copper, enabling their use in activities that required greater durability. Although alloying practices did not develop at the same pace across all regions, the growing distribution of bronze products indicates that communities increasingly recognized the advantages of this new material. Bronze objects often traveled along established exchange routes, demonstrating how metallurgical innovation depended on long-distance networks that linked or rich zones to agricultural regions and coastal settlements. Trade patterns expanded not only in geographic range, but also in organizational complexity. Communities involved in mining began to structure their labor more systematically, coordinating ore extraction, processing, and transportation. These efforts did not require formal central authority, but did depend on cooperative organization within settlements and across connected groups. In turn, agricultural communities produced surplus goods, grain, livestock products, textiles, that could be exchanged for metal or other resources. The resulting interdependence strengthened ties between different ecological and cultural zones, fostering shared technological norms and broader cultural alignment. Settlement hierarchies became more pronounced as certain sites emerged as hubs for production, exchange, or ritual activity. These central places often featured larger architectural structures, more extensive storage facilities, and evidence of craft specialization. Their strategic placement along trade routes, near mineral resources, or within fertile plains allowed them to function as intermediaries between smaller surrounding settlements. Although these centers did not exhibit the full urban characteristics of later Bronze Age sites, they reveal early forms of regional integration that helped shape the contours of emerging social landscapes. The development of defensive strategies also evolved during this period. While many Copper Age settlements had incorporated modest protective features, some later communities constructed more substantial fortifications, stone walls, reinforced ditches, or elevated ramparts. These efforts likely reflect a combination of growing competition over resources, increased movement across territories, and the desire to protect stored surplus or specialized production zones. Defensive structures also indicate shifts in communal organization, as their construction required coordinated labor and shared decision-making. Although their presence suggests episodes of tension, they do not point to widespread warfare, but rather to localized concerns within increasingly interconnected regions. Ritual practices continued to evolve in ways that mirrored broader technological and social changes. Burial traditions in some regions became more elaborate, with larger cemeteries organized into clusters that may represent kinship groups or social categories. Grave goods became more varied, sometimes including bronze objects alongside traditional stone, ceramic, or ornamental materials. These patterns suggest that material culture played an expanding role in expressions of identity, status, or affiliation. In other regions, communities retained earlier burial customs, emphasizing continuity with long-standing symbolic traditions rather than adopting new practices. This diversity demonstrates that integration into Bronze Age systems was neither uniform nor prescriptive. The symbolic significance of metal also shifted during this era. Whereas earlier copper objects often held primarily ceremonial or ornamental roles, bronze items became increasingly embedded in both practical and symbolic spheres. The ability to produce durable tools and weapons contributed to new forms of social expression and may have influenced emerging ideas about leadership, skill, and economic influence. Yet the symbolic world remained rooted in older traditions, indicating that communities adopted new materials without abandoning earlier cosmologies or ritual frameworks. Demographic changes further reinforced transitional dynamics. In some regions, population growth led to the expansion of settlements and the intensification of agricultural production. In others, communities relocated or reorganized into new settlement configurations to adapt to climatic fluctuations or shifting resource availability. These movements expanded the web of regional contact, bringing together groups with different traditions and encouraging cultural exchange. Through these interactions, technological knowledge, including metallurgical techniques, continued to diffuse across social and environmental boundaries. Despite these transformations, localized traditions persisted, particularly in upland or peripheral regions less directly engaged with major trade systems. These communities continued to practice older forms of pottery production, stone tool manufacture, and symbolic expression while adopting metallurgical innovations at their own pace. Their persistence highlights the varied trajectories through which Copper Age societies entered the Bronze Age, emphasizing that this transition was not a singular process, but a constellation of regionally specific paths. By the end of the early 3rd millennium BCE, the cumulative effects of these transitions had reshaped the social and technological landscape of many regions. Communities participated more actively in larger networks. Metal production had become a structured component of economic life, and settlement organization reflected increasing complexity. These developments formed the foundation of Bronze Age societies, in which metallurgy, long-distance trade, and more articulated social systems would play central roles. The chapter settles here, within a world gradually reshaping itself through technological refinement, expanded networks, and adaptive social practices that quietly transformed Copper Age traditions into the beginnings of Bronze Age lifeways. Across the Old World, the legacy of the Copper Age extends far beyond the centuries in which early communities first experimented with metal. The developments between roughly 5000 and 3000 BCE, technological, social, and symbolic, formed a foundation upon which later Bronze Age societies gradually built. These legacies did not arise from a single set of innovations, but from the steady accumulation of practices rooted in earlier Neolithic traditions and refined through Copper Age experimentation. Archaeological and archaeontological research demonstrates that many aspects of later complex societies originated in the quiet, measured transformations of this period. One of the most enduring contributions of the Copper Age lies in its metallurgical foundations. Early techniques, cold hammering, annealing, small-scale smelting, and the use of simple molds formed the base from which more advanced Bronze Age metallurgy emerged. Although copper tools remained limited in utility compared to later bronze implements, they introduced communities to the idea that metals could be shaped, heated, cast, and transformed through skill and observation. These early insights enabled later craftspeople to recognize the advantages of alloying copper with tin or arsenic, leading to harder, more durable tools. The Copper Age thus provided the technical groundwork for the widespread adoption of bronze, influencing economic systems, craft specialization, and regional integration for millennia to come. Craft traditions developed during the Copper Age also exerted lasting influence. Pottery production became increasingly standardized, with households and workshops refining vessel shapes, firing techniques, and decorative styles. These traditions carried into the Bronze Age, where regional ceramic identities became markers of shared cultural practices and interaction spheres. Groundstone tool production continued as well, even after metal tools became more common, revealing the persistence of older technologies alongside new ones. Textile production expanded during the Copper Age and contributed to the growth of specialized weaving traditions that would become central to Bronze Age economies. Together, these crafts reflected the long-term importance of domestic production and the enduring value of skill passed from generation to generation. Settlement planning during the Copper Age displayed patterns that continued into later periods. The arrangement of houses around courtyards, the integration of storage facilities within household spaces, and the use of communal buildings or open gathering areas shaped how Bronze Age communities organized daily life. Larger settlements that emerged during the late Copper Age often became enduring centers of population, serving as focal points for regional networks. Their internal organization, clustered neighborhoods, designated craft areas, pathways guiding movement, anticipated the more complex urban layouts of later eras. These continuities reveal that the spatial logic of Bronze Age settlements did not develop independently, but evolved gradually from earlier Copper Age practices. Symbolic and ritual traditions also persisted, maintaining deep roots in Copper Age cultural expressions. Figurines crafted from clay or stone, decorated pottery used in ceremonial contexts, and deposition practices linked to household or communal spaces continued into Bronze Age ritual systems. Although new materials, such as bronze, entered symbolic use, older forms remained meaningful. Burial traditions, whether intramural or located in designated cemeteries, retained structural similarities, reflecting long-standing attitudes toward memory, ancestry, and the relationship between the living and the dead. These continuities underscore that the symbolic world of Bronze Age societies was not a departure from the Copper Age, but an adaptation and extension of earlier cultural frameworks. Technological knowledge gained during the Copper Age shaped future economic systems in enduring ways. The ability to recognize ore sources, manage fuel supplies, control furnace temperatures, and refine metalworking techniques prepared communities for the more intensive mining and smelting operations of later periods. The establishment of early exchange routes, carrying obsidian, shells, pottery, and small metal objects, formed the backbone of later long-distance trade networks. These routes facilitated the circulation of bronze tools and ingots, linking distant regions into expansive interaction systems that would characterize the Bronze Age and subsequent eras. Social organization during the Copper Age contributed to long-term developments as well. Although communities remained largely egalitarian, subtle distinctions emerged between households with access to specialized crafts or non-local materials. These early forms of differentiation provided the foundation for later social hierarchies. The presence of specialized producers, potters, weavers, stoneworkers, and metalworkers illustrates early steps toward occupational diversification. While not formalized as distinct classes, these emerging roles set the stage for more structured divisions of labor in the Bronze Age. Settlement hierarchies that began to form during the Copper Age, central places surrounded by smaller satellite communities, became more pronounced in later periods, supporting coordinated resource management and regional leadership. Interaction networks that flourished during the Copper Age laid the groundwork for broader cultural horizons in subsequent eras. Communities that participated in long-distance exchange developed shared material traditions and technological knowledge that transcended local boundaries. These connections expanded during the Bronze Age, linking regions across continents in expansive trade systems. The cultural landscapes of later periods, defined by interconnected societies exchanging materials, ideas, and symbolic traditions, were rooted in the quieter, earlier networks of the Copper Age. Through these enduring continuities, in technology, craft production, settlement planning, symbolic life, and social organization, the Copper Age occupies a distinct place in the long trajectory of human development. It represents not an isolated epoch, but a bridging period during which communities refined practices that would shape later civilizations. The changes that emerged slowly and incrementally during this era provided the structural and cultural foundations for the more dramatic shifts associated with the rise of Bronze Age societies. The long-term significance of the Copper Age can also be traced through the ways communities learned to manage landscapes and resources. Agricultural practices refined during this period, crop rotation, mixed cultivation, and diversified herding strategies remained fundamental to Bronze Age subsistence systems. The integration of farming and pastoralism, combined with knowledge of seasonal cycles and soil conditions, supported population growth and settlement expansion. These practices endured because they were adaptable, resilient, and closely aligned with local environments. The stability they provided allowed later societies to support more complex economic structures, including intensified mining operations, larger-scale craft production, and expanded trade. Mining traditions themselves show strong continuity. The earliest extraction techniques, surface collection, shallow trenching, and selective removal of ore-bearing rock, were the basis upon which deeper and more systematic mining eventually developed. Skills related to identifying mineral veins, choosing effective tools, and organizing labor groups persisted throughout the Bronze Age. Some early mining sites remained active for centuries, gradually developing more complex infrastructures as demand for metal increased. The Copper Age thus contributed not only the initial technological insights, but also the practical knowledge required to sustain long-term resource exploitation. The organization of workshops and production spaces during the Copper Age informed later craft infrastructure. Early furnace designs, crucible technologies, and casting methods continued to evolve, but retained the basic principles established in this earlier period. Bronze Age workshops often display more elaborate layouts, yet their foundations, dedicated firing areas, waste disposal zones, and tool assemblages mirror patterns first seen in Copper Age settlements. The continuity of craft infrastructure illustrates how technological systems build upon previously developed knowledge rather than emerging independently. Long-distance exchange networks established during the Copper Age expanded significantly in later periods, but their underlying structure remained consistent. Routes that once carried obsidian and small copper objects later transporting bronze tools, finished ornaments, textile goods, and agricultural surplus. These pathways linked diverse ecological zones and cultural regions, enabling the movement of materials across vast distances. The endurance of these routes demonstrates how Copper Age interactions shaped the geography of later trade systems. Even when new items entered circulation, the social mechanisms of exchange, reciprocity, seasonal gatherings, and intersettlement alliances continued to follow patterns established centuries earlier. Cultural continuities extend deeply into symbolic and ritual domains. Many Bronze Age societies retained figurine traditions, decorative motifs, and deposition practices rooted in Copper Age customs. Shrines and ritual structures, though sometimes more elaborate in later periods, reflect spatial arrangements and symbolic gestures already familiar in earlier eras. Burial customs reveal similar persistence. Whether through intramural burials, extended cemeteries, or collective tombs, attitudes toward ancestry and remembrance maintained strong connections to Copper Age beliefs. Even as metal became more prominent in ritual expression, its symbolic role remained integrated within long-standing cosmological understandings. These continuities remind us that the transition from the Copper Age to the Bronze Age was neither abrupt nor uniform. Instead, It unfolded through processes of adjustment in which new technologies were incorporated into pre-existing social and symbolic systems. In some cases, Bronze Age innovations enhanced earlier practices rather than replacing them. For example, bronze tools complemented established stone tools, while alloyed metals enriched, but did not eliminate existing craft repertoires. Communities adapted new materials and techniques in ways consistent with their historical trajectories, resulting in a layered technological landscape in which old and new coexisted. The social implications of Copper Age developments continued to shape communities long after the period ended. The emergence of differentiated household roles, specialized crafts, and early settlement hierarchies laid the foundation for more formalized leadership and governance structures in the Bronze Age. As settlements became increasingly interconnected, systems of coordination, whether through shared ritual events, cooperative labor, or emerging authority roles, grew more organized. These developments did not represent a complete transformation of Copper Age society, but rather an intensification of patterns that had been slowly forming across generations. In many regions, the memory of Copper Age traditions persisted well into later periods. Settlement sites with long occupation histories retained architectural layouts first developed during the earlier era. Ceramic styles evolved, yet maintained recognizable links to earlier forms. Ritual objects, including figurines and symbolic ornaments, continued to appear alongside new materials. These patterns illustrate cultural resilience and the enduring influence of early practices on later societies. The broader legacy of the Copper Age thus lies not in isolated innovations, but in the cumulative shaping of technological, social, and symbolic systems. It represents a pivotal stage in human history during which communities developed the capacities, technical, organizational, and cultural, that would enable them to participate in more complex economic and social structures. By refining metallurgical knowledge, expanding exchange networks, organizing settlements more coherently, and sustaining symbolic traditions, Copper Age societies established enduring foundations for Bronze Age civilizations. The chapter settles here, acknowledging the Copper Age as a bridging period, whose quiet, gradual transformations contributed profoundly to the long-term trajectory of human technological and social development.